Okay, so we're going to start with homework 2. I'm going to be sharing my screen. So you guys will not have seen the answers yet. So it's a perk of being in this live session is that you get to see the answers. Okay. And what I'm going to do is I'm going to half it between some random notes and the homework itself. So you guys, can you confirm that you see on the left-hand side of the screen like a Microsoft Word document that looks like your quantitative assignment? And on the right-hand side of your screen, a little whiteboard where you can see me scribbling here?
Yeah, I can see that.
Okay, perfect. Okay. So let's get started. All right, so answer the below questions in either Microsoft Word or on paper. If you submit screenshots from the paper copy, please compile them in order as one document. Otherwise, you will not receive credit. When there is math, please show all the work in order to receive any credit for the problems. Consider the market for peanut butter. The demand for peanut butter, demand for and supply of peanut butter is given by these two equations. So I'm going to P equals 50 minus 4. No, let's do this text. Sorry, I'm trying out this new tool because, again, this is new to me. But let's do this with text. Okay. So we have P equals 50 minus 4QD. Can you all see that?
Yeah, I can see that.
Is it small?
Kind of.
All right. Make it bigger. Better?
Yeah, that's good.
Okay. And then you have P, I might as well just do this one word, but whatever. 20 plus 2QS. Okay, so the top one is your demand equation, the bottom one is your supply equation. You can see that besides the fact that they have an S and a D, you can see that because the slope of the demand equation is always going to be negative, and the slope of the supply equation is always going to be positive, right? And so basically you want to find the equilibrium. What P is the price of wholesale peanut butter, Q is the quantity, what is the equilibrium wage and quantity of peanut butter? Okay, so for equilibrium, we always have P equal to P star and QS. So this should really be like a subscript, but I can't do it with this one here. A QD. So you're going to have one equilibrium price and one equilibrium quantity. That's part of the definition of equilibrium, is that they have to be a settling point for the market. Okay, so basically we're solving a system of equations for two variables, P star and Q star. And I'm going to replace QD and QS with Q star and P with P star. And then we can solve. It will let me. So now I have P star is equal to 50 minus 4 Q star. And I have P star is equal to 20 plus 2 Q star. Okay, so there's a few different ways to solve the system of linear equations. I could plug in this over here. I could subtract the two equations. They basically mean the same thing in this particular example. But let's do the first one. We'll plug in 20 plus 2Q star in for P star, since it's already equal to P star. Okay, do you guys follow that step?
Yeah.
Did someone say no?
No, I said yeah.
Okay. All right, so P star is equal to 50 minus 4Q star, and P star is equal to 20 plus 2Q star. So they're equal to each other. right? So I'm just cutting out the middleman of P star. And then I'm going to subtract 20 from both sides. So if I subtract 20 from here, from the left-hand side, I'm left with 30 minus 4Q star equals 2Q star. Okay. Now I'm going to add 4Q star to both sides. So 30 equals 6Q star. And then I'm going to divide both sides by 6. So Q star equals 5. And I just rearrange them here. Are we good up until this point?
Yes.
Anija?
We're good.
Okay, great. So I'm going to move this up a little bit. Okay, I guess that didn't help. Let's keep going. Okay, so we found the equilibrium quantity. Now we need to find the equilibrium price. So we have two relationships here, which give, or two equations here, which give the relationship between price and quantity. So I can plug this Q star into either of these equations, and I will be able to get the same P star. Okay. What I'm going to do, and what I suggest that you guys do when you're solving it in the midterm or on your homeworks, is that you plug it into one, you find your P star. Then you plug it into the other one, and you find your P star. And if both P stars are the same, then you know you've hit equilibrium. Okay. If you have different P stars, then you've done something wrong in your algebra somewhere along the way. So P star is equal to 50 minus 4 times, and now I'm plugging in 5 for Q star. So P star is equal to 50 minus 20, which is 30. Okay. And then let's just check it. P star is equal to 20 plus 2, plugging in Q star of 5. Okay. And then you should get also P star, come on. P star equals 30. So in both cases, my P star is 30. So you know that I have an equilibrium price. Sorry, I'm just trying to figure this one out here. There we go. So P star is your equilibrium price is equal to 30. Q star is your equilibrium quantity. It's equal to 5. Okay. And that is your equilibrium. So that is the answer to 1A. P star equals 30, Q star equals 5. All set? Everybody good on that?
Yes.
Yeah.
Awesome. So let's move on. So next up, I want to graph and label the supply and demand curves. I want to label the intercepts, axes, equilibrium price, quantity, and consumer and producer surplus. Okay. So, Paulina, if I have a graph like this, what goes on the x-axis over here?
X is the horizontal? Or
X is horizontal, but what do I label it with?
price. Or quantity, sorry.
Quantity, yep. Okay, so the price will be the y-axis. All right, Anija, am I saying that right?
It's Anija.
Anija, I'm sorry.
It's no problem.
Anija, which one is sloping upwards and which one is sloping downwards, supply or demand?
I would believe it would be the supply that is going upwards.
Exactly. So demand is downwards. Here we go. That's a D, not an O. Or a P. I don't know. That's a D. It's gross, but it's a D. So we have our supply and demand. I need to label the intercepts. Okay, so we can get the intercepts from the, oh, sorry. I did not mean to do that. We can get the intercepts from the original equation because this is in slope-intercept form, as we call it. Okay, so slope-intercept form is like a y equals mx plus b format. It's the standard form for a line. We have our y is going to be the p star, right? That's the y-axis. So y equals, our x is going to be q star. So y equals negative 4 q star plus 50. So negative 4 is your slope, 50 is your y-intercept. for the demand equation. Okay. So Paulina, what is your y-intercept for the supply equation?
Y-intercept for the supply equation.
Mm-hmm.
Sorry, all those are confusing me.
Yeah, no worries, take your time. So we said that if we put this in a form of y equals mx plus b,
Mm-hmm.
I do not know how to control this thing here. It seems like it's coming up anywhere that it wants to, but whatever. Y equals mx plus b, right?
Yeah.
I'm sorry. Jeez. All right, I guess I'm just gonna have to write this somewhere else. Y equals mx plus b. I'll move this somewhere. There we go. All right, so y equals mx plus b. Y is your slope, or sorry, y is your y-axis good, which is price, as you said. X is x-axis good. I shouldn't say good. Good is the wrong term for it. Y-axis let's say variable. So on the x-axis is quantity. Okay. M is slope, and B is intercept, specifically your y-intercept. Okay.
Mm-hmm.
So if this were rewritten into the form you're probably more used to seeing, it'd be like P equals B, and then it'll be we'll say plus M Q. Okay.
Mm-hmm.
So that's the format we're looking at here. So
Okay.
in the demand equation, we said the y-intercept is 50, okay, which is your B, and your slope is -4, right, which is your M, and it's always going to be the one that's next to the coefficient on the quantity is going to be your slope. Okay, so
Yeah.
going back to the original question, what should be the y-intercept for the supply equation?
The y-intercept is 20.
Yes, exactly. Perfect. All right, so let's go back down here. So I can label this bad boy 20. And label this guy over here as 50. Okay. I'm not as concerned about the x-intercept. We can solve them if you guys want, but I'm more concerned about the y-intercept. To solve for the x-intercept, you would just let y equal 0. So the x-intercept for supply is going to be negative. Okay, and I might as well just do it anyway. So if x is, if y is 0, quantity is going to be -10 for the supply equation. That'll be your x-intercept at -10. And then if this is 0, so 0 equals 50 minus 4q star. Add 4q star to both sides. 4q star equals 50. So divide both sides by 4. So 50 over 4, 12.5 will be your, that's wrong. Will be your x-intercept. So since I guess I technically asked for them, I'll put them over here. 50, -10. Is that right? 50? Oh, I'm sorry, I said 12.5, right? Okay. 12.5. Okay, so those are the intercepts. Okay. We've labeled the supply curve, we labeled the demand curve, we labeled the intercepts, where we found the intercepts by basically looking at the equation and seeing what the B was. Okay, the B is going to be the one that's not being multiplied by your Q when it's in this format of P equals B plus MQ. Okay. Alternatively, if you wanted to find your y-intercept, you just set x equal to 0, or set quantity equals 0. Okay, that's the formal definition. Set quantity equals 0, you get 20 and 50. All right, so that's that. We label the axes quantity and price, and then we want the equilibrium quantity and price. That's going to be where the two lines intersect. Okay. And it'll be Q equals 5 and P equals 30, and we found that up here. Right. And then lastly, we need to label consumer and producer surplus. Okay, Anijah, consumer surplus, is that this one or this one? Is it 1 or 2? Top one or bottom?
I was gonna take it that too, but the bottom.
No, it's actually the top one. So consumer surplus is the top one, producer surplus is the bottom one, and let me explain why that is.
Okay.
So the definition of consumer surplus for an individual is the difference between their willingness to pay and the price they pay. So imagine you wanted to buy a good. Imagine you bought some ice cream, right? And before you entered the store, you're like, I really want this ice cream. I'd be willing to pay $10 for it. Okay. You go into the store and they sell it to you for $6. You're like, awesome. Not only did I get my ice cream, but I got it for less than I was willing to pay for it. So you take away some benefit. Is basically your gain from trade, is that you got $4 more than you, like $4 that you would have otherwise spent. Basically $4 above your opportunity cost. So you're solid. So that's your individual consumer surplus. Now the demand equation, and we showed this in one of the lectures, or two of the lectures actually last week, when we did the John, Jack, and Joe example with the hot dogs, where I had the willingness to pay mapped out, and we saw that once we knew the people's willingness to pays, we could build the demand curve. So there's like an innate relationship between the demand curve and how willing people are to pay for a particular good. Okay, so for instance, at least, or at this point, for example, if the price is 30, there are five willingness to pay. So people are willing to pay for 5 units of peanut butter. Okay, if the price were here, let's say this is like 35, then you'd have maybe 4 people who are willing to pay for peanut butter. Demand tracks the quantity demanded will be like exactly your willingness to pay, the number of people who are willing to pay for that good. Okay. So demand is basically a relationship between your willingness to pay and the price paid. Okay, or it's a map of your willingness to pay. And if you're paying $30 and you're willing to pay $50 or $35 or $32 or whatever, then you're going to get consumer surplus for each sliver of this little area here. So total consumer surplus is going to be the area between the demand curve and the equilibrium price. Okay. So it's basically, if everybody was willing to pay more than they actually had to pay, that is the total consumer surplus for the market. So I'm willing to pay $10 for ice cream. I only have to pay $6, so I get $4 consumer surplus. You're willing to pay $9, you only have to pay $6, you get $3 consumer surplus. You add them all up, you get this area in between the demand curve and the equilibrium price. Okay. On the other hand, producer surplus is the difference between your cost and what you get in return. And what you get in return will be the equilibrium price because you're the one selling the good now. So if I'm the ice cream producer and it costs me $2 to produce the ice cream and I sell it to you for $6, then I get producer surplus of $4 because I'm receiving $6 via selling it to you, and it only cost me $2. All right, so that's your producer surplus. And the same way that if you take enough people's consumer surpluses, you get the area of this graph, producer surplus is the same thing. So supply tracks your cost, and if you're getting a price above your cost, and you're receiving the price because you're the producer, then this area below the equilibrium price, but above your supply curve, is your producer surplus. Okay, so these two areas are your consumer and your producer surplus. And if you sum them up, you'll get your total surplus. All right? Does that make sense?
Yeah, just a little bit. It's just about working on it. I just have to practice it.
Okay, but the ultimate thing is like, if you see a graph and you have an equilibrium price, above it's always going to be your consumer, below it's always going to be your producer. So consumer surplus is the difference between the demand curve and the equilibrium price. Producer surplus is the difference between your supply curve and your equilibrium price. All right? So that's like the key takeaway there. Okay, and then in the next one, I want you to calculate what they actually are. Okay, so we have these two graphs. And I'm going to draw it a little cleaner because that's a mess. So we have consumer surplus. We have producer surplus. I'm not going to label it just because it's already messy enough, and you've seen the labels. 20, 50, and this point here is 5. Okay, and this over here is 0, like on the x-axis. All right, so what we want to find is the consumer surplus, which we said was the area of this triangle here, right, between the demand curve and the equilibrium price. Okay. So now I just need to find what this area of the triangle is. So the area formula for a triangle, area triangle, equals 1/2 base times height. Okay. And then, so what's the base in this equation for consumer surplus? Okay, so consumer surplus, which would be the area between demand curve and equilibrium, let's just call it P star, since that's how we define the equilibrium price. All right, so what's the area for that? So it starts with the 1/2, and then the base is the area along the x-axis. I don't know what this is here. Whoa, hey, oh, I don't want that. It's the area along this x-axis here. Okay. Which goes from, I'm sorry, did you have a question?
Oh, were you asking? I didn't know if you were asking or not.
It can be if you want.
I was just gonna take a guess.
Go for it.
Is it like, because it goes to 5, so is it 5?
Yeah.
Okay.
Okay, and then do you want to take a stab at what the height is?
20?
Exactly.
Okay.
And how did you get that?
Because it's 30 to 50.
Exactly. Perfect. Anaja, is that clear?
Yes, we're good.
Great. So if we just solve that, 1/2 times 5 is 2.5 times 20 should be 50. Alternatively, you could do 1/2 times 20 is 10. 10 times 5 is 50. Okay. So again, we have another triangle. So I'm just going to repeat the formula, 1/2 base times height. Okay. In this case, we have producer surplus, which is the area between supply curve and P star. Oh, an easy way, again, to remember that it's producer surplus is between the supply curve and price, and that consumer surplus is between the demand curve and price, is because demand is about consumers, right? Consumers are the ones who are demanding things, whereas producers are the one who supply things. Okay. All right, so the base is going to be the same. It's the exact same line, so that's going to be 5. And the height will be from 30 to 20, which is 10. So your producer surplus is going to be 1/2 5 times 10, which is 25. And then lastly, I ask you to calculate total surplus, which is your consumer surplus plus your producer surplus, which is going to be 50 plus 25, or 75. I keep writing 85. Okay. And by the way, this is all detailed. I have all the steps on the like answer key, which will be available tomorrow morning. I think it's 6 a.m. I have it set to go. If you're clever, you can take the recording and just see what's on the screen once I post the recording up. But yeah, I do urge you to obviously do it on your own. Okay, so I think so that's it for kind of the calculation part of this question. Then what I do is I throw in some supply and demand shifters, and I ask you which direction should they shift it. So I kind of want to cut off the answer so that we can talk about it without giving away the answer just yet. Can you see the bottom of this here? Like an innovation in food processing?
Yeah, I can see that.
Great. Is it readable?
Yeah.
Okay. If ever it's not readable, by the way, just stop me. I can't see what you're seeing. So, you know, I would need some input on that. Okay. So we have, I'm just going to draw the graph each time. What's on the x-axis? Either of you, it doesn't matter.
The x-axis is quantity.
Yep. What's on the y-axis?
Price.
Okay. I ask that literally every time. So every time I draw a graph, I want that to be like second nature. Okay. What slopes downwards?
The demand.
Yep. So then supply must slope upwards. I just want to take that one off because it turned my demand into a triangle. Let's bring this out. All right, so I give 6 different scenarios, and I want to know, does it shift demand in? Does it shift demand out? Does it shift supply in? Does it shift supply out? Or does it do nothing to either of those? Okay. So we start with innovation in food processing, allows peanut butter to be fortified with extra vitamins and minerals without additional input costs. Okay. So there's no change in input costs, so it shouldn't really affect supply. But having additional vitamins and minerals will make it more popular among consumers. If something's more sorry, Jeff.
Yeah, I think we were just about to say the same thing. So because it's more popular and it's selling more, there's a higher demand for it to be in stock.
Exactly. So what happens to the demand curve? Does it go out or in?
It'll go out.
Exactly. So I shift demand out from D to D prime. The graph shouldn't go this far down, but I'm not a great drawer. So there you go. Input costs are not changing in this example, only the quality of the product itself. People like the product more, so demand should shift outwards. Okay. What about the price of jelly decreases? Okay, so what goes on the X-axis?
Quantity,
Yep. What goes on the y-axis?
price.
All right, so demand is downward sloping, supply is upward sloping, and the price of jelly decreases. So first I'd ask, is jelly a complement good or a substitute good to peanut butter?
Complement.
Right. And in your own words, like your own understanding, what does it mean for it to be a complement good? Complementary good?
They go together.
Yeah, exactly. Two things that go together. So peanut butter and jelly is obviously something that you'll probably consume at the same time. And that's the definition I like. The technical definition of a complement good is a good that when its price increases, demand decreases. Okay. So the price of jelly decreased, so the demand for peanut butter should increase. Okay. So basically, if you let's say you don't care about jelly sandwiches, you don't care about peanut butter sandwiches, but you care about peanut butter and jelly sandwiches, the price of a peanut butter and jelly sandwich has basically gone down. So you're going to consume more peanut butter and jelly sandwiches, which will increase the demand for peanut butter. Okay. So the price of a complement goes down, the demand for the thing to which it complements goes up. Okay. If I had said, so this is not on the homework, but if I had said, this is the demand for peanut butter, this is the supply for peanut butter, and the price of peanut butter decreases, what should the shift look like?
If price goes down, the demand goes up, right?
You said the supply goes down?
Oh, we're talking about supply. Oh.
No, I thought that's what you said. I'm sorry.
I thought you
What
meant
did you say?
so if the price goes down, the demand goes up, right?
Does it shift up?
No.
Exactly. Exactly. So if I said the price of peanut butter decreases and we're looking at the demand for peanut butter, the relationship of the demand curve is between price and quantity of peanut butter in this case. Okay. So if the price of peanut butter decreased, then it would look something like this, just a movement along the same demand curve. So going from here to here, here to here, something like that. The underlying relationship of the demand curve would not have changed. Okay. But that's not on the homework, so don't worry about that. Just a kind of a comprehension question. Just know that there's a difference between a supply shift and a movement along or a demand shift and a movement along the demand curve. So this is jelly, so there's a demand shift for peanut butter because it's complement good. But if I was looking at peanut butter and how does that affect, if I was looking at the price of peanut butter and how that affects demand of peanut butter, that would be a movement along the same demand curve. All right. So now I have the price of peanut butter 2 or PB2, which is like a powder that's of peanut butter. So it's a substitute good, increases. So the price of a substitute increases. I should have asked you guys what's on the X, what's on the Y, but whatever, this one's okay. All right, the price of a substitute increases. What happens to supply and demand? No biters? Okay, that's fine. So imagine you had, you were in a grocery store and you had two things in front of you, peanut butter and peanut butter 2 or PB2 or Nutella or whatever. Something else that you would consume, a substitute good. Okay. And all of a sudden, the thing that you used to eat, its price increased. What would you do? You would eat the other thing, the thing which is price would stay the same if it increased enough, right? So you'd expect if the price of peanut butter 2 increases or PB2 increases, that you would consume more peanut butter. And if you're consuming more peanut butter, it's because of a demand shift. Okay. So the price of a substitute good increased, so demand should shift outwards. I think so far I've had 3 demand shifts outwards in a row, right? Yeah. That's about the change. Price of a substitute increased, so demand should increase. All right. Now we have, so there's added micronutrients in a rival product. So the rival product essentially becomes more popular. Okay, what goes on the x-axis
Quantity.
and on the y,
Or price.
right? And what is upward sloping?
Supply.
Mm-hmm. And downward sloping?
Demand.
Good. All right. So imagine you're in the same scenario and you have 2 things in front of you, peanut butter and Nutella, and you find out, oh, Nutella is super healthy for me. Are you going to consume more or less peanut butter for the same price?
Less.
Less. So your demand should shift inwards. Okay, because peanut butter is now less popular. The popularity of a substitute increased. So in Nutella's terms, for like the Nutella graph, Nutella's demand would shift outwards. But for peanut butter, the demand should shift inwards. Okay. Okay. I think there's 2 more. Okay, so there's a recession. Okay, a recession is obviously bad for individuals, right? I guess I took that as something that people know because, you know, you hear it on the news and stuff. So a recession is bad for your income. Okay, and peanut butter is considered a normal good. Okay, either one of you, what does it mean to be a normal good?
It's used more.
Excuse me?
It's used more.
Yeah, the more money you have, the more you're going to consume it. So it's literally a normal good. It's something that when you can afford more of it, you're going to buy more of it. Okay, and the opposite would be an inferior good, which is as you like have less and less money, you end up consuming more inferior goods, usually because you're substituting away from normal goods. So in the review slides, I have a list of some things that I consider like normal and inferior goods. So I'll just do one. So Dr. Bob, which is the giant brand of Dr. Pepper, and Dr. Pepper, right? The more money I have, the more likely I am to consume more Dr. Pepper because I like Dr. Pepper. Okay, but let's say I started losing money, I'd go to its cheaper substitute, Dr. Bob, which might be made with, you know, something that's a little more sugary or something like that. So the less money I have, the more likely I am to consume Dr. Bob. The more money I have, the more likely I am to consume Dr. Pepper. But for me, I would just rather consume Dr. Bob because I'm weird, I guess. Dr. Bob is the same. It tastes the same to me. All right, anyway. So peanut butter is a normal good. Your income has decreased. What goes on the, whatever. So your income has decreased for normal good. Do you consume more or less peanut butter?
Less.
Okay, in which direction does demand shift?
Downward.
Exactly. So demand should go inwards. So you have a decrease in demand. All right. Normal goods are goods whose demand increases as consumer income increases. So demand should decrease when there's a recession. Any questions at this point?
No.
Cool. Okay. Unfavorable weather conditions decrease, that should be decrease, not decreases, the amount of peanuts harvested this year. Okay. So do you think this is a demand shifter or a supply shifter?
A supply shifter.
Right. And do you think it'll be inwards or outwards?
Inwards.
Okay. And why do you think that?
Because they're not making as much.
Yeah, exactly. It's become more expensive to make peanut butter, basically. So you'd expect that for every price, they're going to sell less peanut butter. Okay. So it's basically like peanut butter's become rarer. Okay, more rare, whatever the word for being more rare is, if it's rarer or more rare. It's hard to say. All right, so inputs for peanut butters are now harder to come by. They're more expensive, so supply of peanut butter should shift inwards. Okay. Are we good until this point?
Yes.
Okay, good. This next one I think is a little trickier. I debated whether I should put it in or not, but I wanted to keep it in case I do put it into the midterm. I don't want to say that it's improbable that I put it in the midterm, because it might happen, but I'm leaning towards no. All right. So there are three consumers, Whitney, Donna, and Tina. They each have some demand for whiskey. And I'm going to do this one in Excel, actually. So I'm going to bring this over. So I'll do this like I did in the lecture slides. Okay. So they each have some willingness to pay. So Whitney, Donna, and Tina. So for one shot, she's willing to pay 5, for second 4, 3 for the third. Donna, 6, 2, and 1. And Tina is 5. And you don't have to do this. This is just because it helps me helps me recap the problem. Okay. So basically, I want to know what if P equals something, what the demand will be for that. Okay. I think I'd go up to 9, right? And then we'll have Whitney, Donna, Tina, and all. Okay. So if the price is 0, Whitney's willing to pay for all 3 shots. Donna's willing to pay for all 3 shots. Tina's willing to pay for all 3 shots. So I should get 3, 3, 3. And the total is going to be sum of these 3. Does that make sense for how I got those 3?
Yeah.
Okay. So if the price increases to 1, Whitney's still willing to pay for all 3 shots. Donna is basically able to pay for all 3 shots. If it goes a cent above, then she wouldn't be. Tina is still willing to pay for all 3 shots. So it's also going to be 3, 3, and 3. Now, if the price goes up to 2, Donna no longer is willing to pay for that third shot. She's only willing to pay for the first 2 shots. The rest are willing to pay for all 3. So I should have 3, 2, 3. Okay. Now, if the price is 3, Donna's not willing to pay for the second shot either, and Tina is no longer willing to pay for the third shot. So Whitney is willing to pay for all 3. Donna's only willing to pay for 1, and Tina is willing to pay for 2. Okay. And if the price is 4, Whitney's willing to pay for 2. Donna's willing to pay for 1. Tina's willing to pay for 1. Okay. So 2, 1, 1. The price is 5. It'll be 1, 1, 1. The price is 6. Now Whitney doesn't buy anything. Donna will still buy 1. Tina will buy 0. The price is 7. It'll be 0, 0, 0. And 0, 0, 0. Do I go up to 9? That seems high now. Okay, I only go up to 7. Good. Okay. So given the price, we have each individual's quantity demanded, and we have the total quantity demanded. So I'm just going to call this QD. Oh, caps lock. QD. Okay. And then if we wanted to, we could graph these two, and then we'd have our little demand equation, one thing to take note of is that this is, I don't want to do that either. The X and the Y are reversed as it shows here. So the Y-axis should be price, which will be column 5. The X-axis should be column 1. All right. So then I want to add legends just to, so we want quantity on the X-axis, which is what we got. And we want price on the Y-axis. Where'd it go? Price. Okay, and we can just confirm when price is equal to 7, you get 0 for quantity. When price is equal to 6, we should get 1. Yep, so it looks good. And then we would just connect these graphs. Let me see if I can bring this in the whiteboard. It came in really small. Let's make it a lot bigger. All right. So now I kind of want to draw on this, and I want to connect the points, which I think I said you don't have to. Oh, no, I didn't say that. Never mind. You do have to connect the points. So when price is 6, we go to 1. When price is 5, we go to here. And it should be a stair stepper because it's not like an infinite number of consumers, and also because I told you that it should look like stairs. Typically when we're dealing with demand equations, they're going to be like a line. In this case, because there's only 3 consumers and we know exactly what their willingness to pay are, we would do a stair stepper. Okay, so it should look like this. Does that make sense?
Yes.
Okay. So alternatively, you didn't have to do it in Excel. I actually don't expect people to do it in Excel. It's just, the way I do it. You can, if you wanted to plot them like this, and then just label the points. One of those points is off. But, if you just wanted to plot them using pen and paper, that would be my way to do it if I weren't, in quarantine. But that's like your call. Okay. So there it is. And then suppose the price was $4. I want the consumer surpluses. Okay. So let me do price in blue. Call that P star. Okay. So the first consumer surplus should be this, and someone gets this, someone gets this. Okay. So someone's getting 7 minus 4 consumer surplus, someone's getting 6 minus 4, and someone's getting 5 minus 4. So that should be 3 plus 2 plus 1. In fact, two people are getting 1 consumer surplus. This one quantity went out by 2. That should be 7. Okay, easier way to do that. So that's just it graphically. That's how you show that. But if you wanted to do it this way, this probably makes more sense. So let's look at their willingness to pays again. Or I could do it here. So if the price is 4, we know that Whitney buys for buys with WTP $5 and $4. Donna buys with willingness to pay $6, and Tina buys with willingness to pay of $5. Okay, so there's 4 goods consumed in total, each with different willingness to pay. Consumer surplus for the individual is equal to willingness to pay minus your price paid, or P star. So that'll be 5 minus 4 plus 4 minus 4 for Whitney, okay, because she buys 2 of them. So one she's willing to pay for 5, second one she's willing to pay for 4. For Donna, it'll be 6 minus 4 is 2. And for Tina, it'll be 5 minus 4 is 1. So we have 1 plus 2 plus 1. And I said I added this one in the first time around, and I screwed that up because 0 people consume at $7. So I want this one here. I'm sorry about that. I was not thinking. So it should be 4. My bad on that. Okay, so basically you take what they buy and what they're willing to pay for what they buy, and you subtract it out from the price they pay. Okay, so Whitney gets $1 consumer surplus, Donnie gets $2, Tina gets 1, and in total 1 plus 2 plus 1 is 4. Okay, does that make sense? I did a poor job explaining that, and I'm willing to go back over it if you'd like.
Yeah, so you just subtract what they paid and what they were willing to pay?
Exactly.
Okay.
Given that they bought the good, right? You're obviously not, if the price is greater than your willingness to pay, you're not going to buy the good. So you're not going to get any consumer surplus on that. But if they bought the good, then they should. Does that make sense?
Yes.
Yeah.
Cool. Okay, I think that's it for that question. Now on to this last one here. All right, so we have a Pareto efficient allocation. And this doesn't really matter, but players 1's utilities is the X coordinate, player 2's on the Y. For a point to be Pareto efficient, you shouldn't be able to find another point at which you can improve both players or improve one player without hurting the second player. All right. So for example, if there's an allocation here, so if I'm considering 2-9 and I want to determine if it's Pareto efficient or not, if there's a 3-9, okay, so that means I'm improving player 1 without hurting player 2, then 2-9 cannot be Pareto efficient. Okay. Or if there's 2-10 or 2-11 or 3-10, okay, if you can improve from 2-9, if you can improve player 1 without hurting player 2, or if you can improve player 2 without hurting player 1, or both, then 2-9 cannot be Pareto efficient. So the goal is I'm going to go through one by one, compare 2-9 to 13-5, compare 2-9 to 11-2, compare 2-9 to 8-7, etc., seeing if there's a way to improve both players or a way to improve one player without hurting another. Once I find a point where I can improve one player without hurting the other, then I know that 2-9 cannot be Pareto efficient. If I've gone through every point and there's no point where I can better one person without hurting the other, then 2-9 must be Pareto efficient because there's no allocation where you can improve player 1 without hurting player 2 or vice versa. Okay. So I need to consider all like all 5 matchups basically, 2-9 versus 13-5, 2-9 versus 11-2. But once I find that something isn't Pareto efficient, then I no longer need to consider it. Okay. So let's start with 2-9. And I did this shorthand in lecture where I did like this plus or plus minus or plus, I think it was plus equal or plus 0. I don't remember which I used. Okay. But basically what I'm doing is saying going from 2-9, going from and moving to, what's the gain for player 1? What's the gain for player 2? P1, P2. So player 1 benefits going from 2-9 to 13-5 because player 1 goes from 2 to 13. Does that make sense?
Yes.
Okay. So I'm just writing like a little plus there. Okay. And basically, if I can find an allocation that's a plus, oh, it wants me to do a formula. If I can find a plus, if I can find a plus equals, if I can find an equals plus, then I know that both players are being better. Both players do better. I said P1 does better. P2 does the same. P2 does better. P1 does the same. If these 3 things are, like if I move from here to here and any of these 3 things happen, that violates my definition of Pareto efficiency. That means my going from point is not Pareto efficient. Okay. Also, if I see a minus or a minus equal or a equal minus, then if I were to switch the going from and moving 2 points, then I'd be in these 3 scenarios. So like if I were to just switch what I'm considering, then the moving 2 point can't be Pareto efficient. But let's take it a step at a time. So basically what I'm looking for is there a plus, a plus equals, or an equals plus in any of the matchups from 2-9 versus any of these 5, okay? And once I find that, I can eliminate 2-9. If I can't find it, then I can say that 2-9 is Pareto efficient, okay? So 2-9 to 13-5 is a plus minus. So then I want to do 2-9 versus 11-2, okay? Going from 2, I have a plus. Going from 9 to 2, I have a minus. So I'm looking for a plus or a plus equals or an equals plus. So I can't eliminate. Nope, this should say eliminate, not eliminated. Okay, what about 2-9 versus 8-7? Okay, going from 2, I have a plus. Going from 9 to 7, I have a minus. Can't eliminate. 2-9 versus 6-10, WIP. I don't know if you guys are in the Philadelphia metro area, but it's Pavlovian for me. Anyway, bad jokes aside, 2-9 versus 6-10. Player 1 does better. Player 2 does better. What does that mean? I've increased player 1's allocation without hurting player 2, or you could say it the other way, I increased player 2's allocation without hurting player 1. For something to be Pareto efficient, it must be impossible to improve both agents or improve one agent without hurting the second agent. Basically, it's only Pareto efficient if I can't make one player better without hurting the other. In this case, I can make both players better, so I can eliminate. Okay. So 2-9 is not Pareto efficient. 2-9, not PE. Right? So I would just cross that off. I don't want to play with this document because this is the solution key. But I can cross out 2-9. somewhere. Boom. All right, next point, 13.5. So I could go step by step and say, hey, does 13.5 compare to 11.2? How does 13.5 compare to 8.7, 6.10, 4.2? But this should not be struck through. Easier than that. I know that 13.5 is the best that player 1 can do. There's no other allocation that matches or improves upon 13.5. So I could go step by step, and you might want to if you're unsure. But I know that going from 13.5 to any other allocation will hurt player 1. To any other allocation will hurt player 1. So I can't improve player 2 without hurting player 1. So 13.5 must be Pareto efficient. Okay. So you could do the matchups if you don't believe me, but it's pretty straightforward. If this is the best that player 1 can do, and there's no other 13s here, then I can't make player 2 better off without hurting player 1. Okay. So 13.5 is Pareto efficient, 2.9 is not. Okay. We don't have to consider 2.9 anymore in our matchups. So once it's eliminated, we know that it's kind of irrelevant. And the reason is, like, once I consider 11.2 versus 6.10, for example, 6.10 is better for both of these people. So it doesn't, if I can say something about 6.10, then I can automatically say about 2.9. Like 2.9 is trumped, it's beaten out. So we don't need to consider it anymore. All right, so let's do 11.2. All right, so let's start with 13.5. So I have a plus for player 1, plus for player 2. I make both better without hurting either. So it must be not PE. Not PE can eliminate. So we found the plus plus. We can eliminate 11.2. We no longer have to consider it. Okay. So anything like if we're looking from 6.10 to versus 13.5, 13.5 is going to be better in both regards than 11.2. So we don't need to consider 11.2 anymore. All right. What about 8.7? So 13.5 versus 8.7 will be a plus, minus, can't eliminate. 8 going from 8.7 to 6.10 will be a minus, plus, so can't eliminate. Going from 8.7 to 4.2 will be a minus, minus. So we can actually eliminate 4.2, but I'd rather just do that in the right terms. But you see that it's a minus, minus. So if I were to be moving from 4.2 going to 8.7, it would be a plus, plus. So we can say that it's eliminated. Okay. So 8.7 we just compared against, so we did it against, we don't need to compare 2.9, we don't need to compare 11.2. We compared it against 13.5, 6.10, and 4.2. So all that's left is itself. So 8.7. So 8.7 couldn't be eliminated by any other point, meaning I can't improve player 1 without hurting player 2. Also, I can't improve player 2 without hurting player 1. So 8.7 is Pareto efficient. Does that make sense?
Yeah.
Yes.
Great. Okay, so then we'll do 6.10 now. 610 versus 13.5 be a plus minus 610. So now we have 8. So we've already eliminated 2.9 and 8.7, or sorry, 2.9 and 11.2. So we have 8.7. So that would be a plus minus, and then 610 versus 4.2 should be a minus minus. So there's no other points. So 610 can't be eliminated, is Pareto efficient. And then lastly, we have 4.2. So let's do 13.5. That'll be a plus plus. So 4.2 can be eliminated. Okay. So basically we're left with 4.2, 2.9, and 11.2 are dominated. They can be improved upon. So they're not PE. And then we have 13.5, 8.7, and 6.10 are PE. There's no way to increase player one's benefit from 13.5 without her, or sorry, there's no way to increase, well, there's no way to increase player one's benefit from 13.5 at all. There's no way to increase player two's benefit from 13.5 without hurting player one. There's no way to increase player one's benefit without hurting player two from 8.7, and there's no way to increase player two's benefit without hurting player one from 8.7. And then with 6.10, there's no way to increase player one without hurting player two. Okay, so these are the 3 Pareto efficient allocations. And that's really the end of the homework. Any questions on quantitative assignment 2?
No, thank you.
All right. Let's do quantitative assignment 1 then. Or do you guys want to take a little bit of a break or what? Let's just do it. Cool.
Yeah, we can.
Okay. So these answers have kind of been up there for a little bit now. But I think it helps to have someone explain them. So let's just jump in. Give me a second. I'm kind of hungry and there's actually protein in here, so. Okay. So we have our comparative example questions now. And basically, the purpose of this homework was to get you to think about efficient production and how dividing up labor can make for basically gains from trade. But when you divide up your labor based on who's more efficient at producing something, both parties can end up benefiting. All right. So we have Danny and Luke, and they're taking 4-hour shifts in a whiskey distillery. Okay. And this is actually a true story. There was a whiskey distillery that started making, they were making hand sanitizer, but same kind of thing, and probably masks, I don't know. But a lot of industries have actually shifted to making masks and hand sanitizer and whatever because of the pandemic, because people aren't really buying, or they weren't really buying whiskey for the first 2 months of the pandemic when people weren't going outside. All right, so Luke makes 16 masks per hour or 30 bottles per hour or some combination in between. Danny does 12 or 20. Okay. So in a table, write the number of masks and bottles that Danny can make in the 4 hours, starting with Danny makes only whiskey and no masks, and progressing until Danny makes only masks and no whiskey. So this is just simple multiplication. If Danny spends 0 hours on masks and he makes 12 masks per hour, he's making zero masks, right? And if he spends 4 hours on whiskey and makes 20 bottles per hour, he's going to make 4 times 20 bottles, so 80 bottles. And it just progresses like that. So if Danny spends 1 hour on masks, 3 hours on whiskey, 1 hour times 12 will be 12 masks. 3 hours times 20 will be 60. 2 and 2, so 2 times 12 is 24. 2 times 20 is 40. 3 times 12 is 36. 1 times 20 is 20. And then 4 times 12 is 48. 0 times 20 is 0. Pretty straightforward, I hope, right?
Yeah.
Cool. And then, do the same for Luke. So it'll just be 4 times 30, 0 times 16, 1 times 16, 3 times 30, 2 times 16, 2 times 30, et cetera, et cetera. All right. So then I asked to draw the production possibilities frontier. Okay, and I say that mass should be on the x-axis. I'm going to do M and W for masks and whiskey. I guess I'll just write it out, whatever. W is for whiskey. All right. So I have masks on the x-axis, and the only reason that it's on the x-axis is because I asked you to put it there. It could be on either. So Luke's graph. All right, and we want the production possibilities frontier. So we have some points already graphed out. So I could do this point and this point and this point. So 0, 120, 1690. You can do that. Alternatively, we know that it's a straight line because of the shape of the production possibilities frontier. For an individual, it should be a straight line. So I just really need the intercepts. And we know it has a constant slope because they have a constant opportunity cost by virtue of the problem. So it'd just be like a line. So if I wanted to plot these points, I could, but it just saves time to just do the intercepts. And that's because it's an individual PPF with a constant opportunity cost because they have a constant rate of production. Okay. If I said like, as Luke produces more bottles, it becomes harder to produce bottles, then you would have like a curved opportunity or a curved production possibilities frontier. So you would need the individual points, but that's not something we're going to do in this class, right? So what are Luke's 2 points? He has 120 bottles of whiskey when he makes 0 masks. So if he spends all of his time making whiskey, he makes 120. And then his x-intercept should be 64. Okay. And for those points, I'm just looking over here at what we did in the problem above. So 64, 0 is one point on the graph, 0, 120 is the other. And I can just connect them with a straight line. And again, I know it's a straight line because he's got constant opportunity cost because he's always producing at the same rates. Okay. So what do I ask you? Label axes and intercepts, which I just did. So that's really the end of that problem. And then I want Danny's. That looks like it says pay me's, but whatever. So whiskey, masks. And again, I can just look up here. So 48.0 is going to be 1 point. And 0.80 is going to be another. And it's an individual production possibilities frontier, so it's just going to be a straight line. So we can just connect those 2 points. So that's really it for question 2. Okay, any questions on that?
No.
Cool. Am I going too quickly?
No.
Okay. Am I going too slowly?
No, it's okay.
Okay, perfect. It's always hard to gauge when I'm not looking at your guys' faces and you're like, like when you do the dog tilt. All right. So next up, I asked the opportunity costs. So really all you have to do is you could just divide these two by each other. You could divide the rates by each other. So I usually stick to looking at the rates because once you're at this point, you've already done some math. So it's just easier to stick with what you're given in case you made a mistake along the lines. Okay. So if Luke makes 16 masks, that means he's losing 30 bottles, right? So his opportunity cost for 16 masks is 30 bottles. Luke's op cost for 16 masks is 30 bottles. Remember, opportunity cost is always going to be cited in terms of the other good. Okay. So Luke's op cost for one mask is just going to be 30 divided by 16 bottles. And 30 divided by 16, we could, if we wanted to, I wouldn't take points off if you didn't. We could just simplify that to 15 over 8, which I think comes out to 1.875 bottles. So that is 1.875 bottles is Luke's op cost for masks. Okay. Your opportunity cost for masks is always going to be a number of bottles, because it's always the good that you're giving up will be your opportunity cost. Okay. What about Luke's op cost for one bottle? It should be in terms of masks, first of all, and it should be the reciprocal, 8 over 15 masks. Okay, so you could do it the long way. You could say for 30 bottles, he's giving up 16 masks, so his opportunity cost should be 16 divided by 30, which reduces 8 to 15. Or you could just say it's the reciprocal. 15 divided by 8 should be flipped around, so it's 8 over 15. Okay. Remember, I should have defined this in the beginning when I started explaining the problem. But your opportunity cost is basically the thing that you're not doing, the foregone option. So if you're not making masks, you're making bottles, right? So your opportunity cost for a mask is some number of bottles. Right. And I didn't ask this, but we'll need it for later. So Danny's opportunity cost for one mask is just going to be, so if he's making 12 masks, he's giving up 20 bottles. So if he's making one mask, he's giving up 20 divided by 12 bottles. And Danny's op cost for one bottle will be 12 divided by 20, or 6 divided by 10, or 3 divided by 5 bottles. Just wanted to simplify that and had to do it in my head. Sorry about that. So this should be 20 divided by 12, or 5/3, aka 5/3 bottles. Okay. Clear on that?
Yeah.
Anijah, you clear on that?
Yes, we're good.
Cool. Okay. So then I ask, who has the absolute advantage in making masks? And I think most people end up getting this one right. But just to clarify, absolute advantage is if I give you a number of hours or a number of bottles that they make in an hour, and they make more than the other person, then they have absolute advantage. Okay. So Luke makes 16 masks. Danny makes 12 in an hour. So Luke makes more in an hour than Danny. So Luke has absolute advantage. Luke makes 16, Danny 16 masks per hour. Danny makes 12. Luke has absolute advantage in masks. Okay. Luke makes 30 bottles per hour. Danny makes 20. 30 is greater than 20. Luke, should specify this one, 16 greater than 12. So 30 greater than 20, Luke has absolute advantage in masks. Is that clear?
Yes.
Yeah.
Perfect. All right, I'm going to leave this. I want to see the opportunity cost. Because next up I ask about comparative advantage. So Luke has absolute advantage in both. Who has comparative advantage in making masks? So comparative advantage is basically means you're able to make more of a good more efficiently. So it's not about how much you make per hour, but how many masks you make per bottle. Okay, so if you make more masks per bottle than the other person, then you have comparative advantage. Another way of saying that is if you have a lower opportunity cost, you have comparative advantage. Okay, so comparative advantage is lower opportunity cost for that good. Okay, so Danny's op cost for a mask is 5/3 or 1.66 bottles. Luke's op cost for a mask is 1.875 bottles. 1.66 is less than 1.875. Danny has a lower opportunity cost for masks, aka he makes more masks per bottle. Danny, therefore, has comparative advantage in masks. Okay. And then what you could say is if person X has comparative, let's use Danny. If Danny has comparative advantage in X, Luke must have comparative advantage in Y. Advantage. The reason is, let's say I have 1/5 or 1/3. Let's say my opportunity cost is 1/3. Your opportunity cost is 1/2. So 1/3 is less than 1/2. So I would have comparative advantage in that good. But the other good, our opportunity costs are going to be reversed. So it would be 3 versus 2. You're going to have a lower opportunity cost. So necessarily, if I have comparative advantage in one good, you have comparative advantage in the other good. So you could say Luke has comparative advantage in bottles necessarily. Alternatively, what you could do is you could do it the other way around. You could just like redo the steps. Luke's opportunity cost for a bottle is 8/15, which I think was like 0.53. Danny's was 0.6. 0.53 is less than 0.6. So Luke should have comparative advantage in bottles because he has a lower opportunity cost. Okay. That's like another way of getting to the same thing. So Danny has comparative advantage in masks. Just want to write this one more time. Danny has comp advantage in masks. Luke has comp advantage in bottles. Hi, Daniel. Just so you know, you're being recorded, okay? You know, if you don't want to be recorded, I guess you'd have to stop. But if as long as you're cool with being recorded, like your voice, you don't have to, obviously you don't have to have your camera on or anything. But as long as you're cool with being recorded, we'll just continue. Okie dokie. So we're in the middle of quantitative assignment 1. We already solved quantitative assignment 2. And we're just going over the answers for quantitative assignment 1. And we just found that Danny has comparative advantage in masks and Luke has comparative advantage in bottles. Okay. So now we're moving on to here, question 8. Suppose they must make 190 bottles and 6 masks. Who would you rather assign to make those masks before getting back to the bottles, and why? So this is a question that I put up every semester, and every semester people get it wrong, and the majority of people get it wrong, and I try to stress it. So please pay close attention, because I've said it a few times in lecture, and people still get it wrong because I don't think they're watching lecture. Don't go by absolute advantage. Absolute advantage means you could do both things better, or you could do one thing better, but it doesn't mean you have comparative advantage, and it doesn't mean you're more efficient at something. Okay? Imagine I gave Michael Jordan a mop, and I said, or imagine you had the Chicago Bulls in 1997, and you found out that Michael Jordan is a very, very fast at sweeping up the Bulls stadium, right? You're still not going to give him a mop, because if he's sweeping the stadium, that means he's not playing the game, right? So even though he's faster at sweeping the stadium than your average janitor, that doesn't mean he has comparative advantage, because the janitor is not going to be taking his spot in the Bulls, in the Bulls roster. Michael Jordan is more efficient at producing basketballs per whatever cleanliness than the janitor is, even though he's better at doing both things. So even though Michael Jordan has absolute advantage in both basketball and sweeping, doesn't mean he should be sweeping and then getting back to the game, because then you'd have an insane scenario and the Chicago Bulls management would all be fired. So don't go by absolute advantage. It does not make sense, because you're taking someone away from the thing that they're more efficient at. Okay? Just because they're faster at something doesn't mean they're more efficient at something. All right, that's my rant. So comparative advantage is how you're going to determine whether or not to assign someone to a particular good. So regardless of how I ask 8A or 8B, it should be that as long as there are masks to be made, Danny should be the first one making masks. And if there's extra masks that need to be made once Danny spent all his time, then Luke can help. Sorry, my cat, she does this every day around this time. As long as there's bottles to be made, Luke should start making bottles. And if there's still bottles that, once he's spent all of his time making bottles that they need to make, then Danny can pitch in. But you should never start Danny to bottles, and you should never start Luke to masks, even though Luke makes more masks per hour than Danny does. Always go by comparative advantage. And I showed this in lecture, where if you did do it the other way around, where Luke, well, I didn't, and it was Kendrick and Marshall, but if you gave the person who doesn't have comparative advantage, who has absolute advantage in a good, if you gave them that good, you'd end up making less as a team. Okay, if you gave Michael Jordan a mop, and you said, all right, you hold down the fort for Chicago Bulls, janitor, and Michael Jordan will clean, and then when Michael Jordan's done cleaning, which he can do faster than you, then he'll get back to the game. You're going to have less game and you'll have less points and less cleanliness than you would if you let Michael Jordan do his thing and you let the janitor do his thing. Okay? So always give it to the comparative advantage person. If you don't, so if you had a combined PPF, so this is, let's stick with the Jordan example. Game. So game is or points, whatever, and cleaning, I guess. If those are your two goods, or one, or both are services actually, and you gave them to the correct comparative advantage people, you should have a graph like this. And if you gave them to the incorrect comparative advantage people, you should have a graph like this. They should be connected, but you'd have a graph like this. And the justification for it is this person has a higher opportunity cost, and this person has a higher opportunity cost. So this person has a higher opportunity cost in terms of games per cleaning, and this person has a lower opportunity cost for games. So you're starting the person with the wrong opportunity cost, basically the wrong comparative advantage to make the games, and he's got a higher opportunity cost for games. Okay, so you'd have a graph like this. And finally, the person who has a lower opportunity cost for games is gonna pitch in. Here, the person with a lower opportunity cost for games starts, and then it goes to the person with the higher opportunity cost to help out if we need more games, okay? Or more of the game time. Okay. Hey, Anthony, just so you know, you're being recorded. If you're not cool with that, I'd ask you to leave, and you could check out the recording on Blackboard when we're done. But as long as you're cool with being recorded, you can stick around. And it's just your voice that's being recorded unless you turn on your screen. So anyway, we're talking about quantitative assignment 1, and I'm just going through, now I'm at question 8, and I'm talking about you want to give the person with comparative advantage the thing that they have comparative advantage in. So Danny's got comparative advantage in masks, you should start with masks. Luke has comparative advantage in bottles, so he should start with bottles. And also, I know that you wanted to you had questions about quantitative assignment 2. You actually missed that part. We started with quantitative assignment 2, but it'll be in the recording when we're done, so you can check that out. All right. Is that okay?
Yeah, that's fine. I was going to look through. I was going to ask you what slides on the lecture, like how there's pages.
Mm-hmm.
Do you remember what page it was where you went over the example of the chart at the end of quantitative assignment 2?
I'm not sure if it was on a slide, but I can show you the. So if we go to the lecture slides, you see the addenda, these things here. There was like a little Excel file.
Yeah.
So I went through them and I built the demand function. So it's this over here. So you want to find the lecture where I talk about these videos over here.
Okay, and explains how you got each answer according to the data that it was given.
Exactly. So just like so this was like Donna, Whitney, and Tina. I had to run this as the pay.
Yeah.
And then I used that and I built this, which should look a lot like the Donna, Whitney, and Tina example.
Yeah.
And then from there, I built the demand curve, which I think is the yellow one here.
Okay.
So I did it twice. I did it. This would have been towards the end of the week. So we're end of week 4 lecture. And then I did it again at the beginning of the week 5 lecture. And actually the week 5 lecture does have corresponding slides in it, and that's not the right one. It is lecture 4B. So if we go to here, so I take the willingness to pay for these guys.
Yeah.
And I use it to draw a graph. So if you can find the lecture notes that correspond to that, the lecture video that corresponds to that would be your best bet.
Okay, and you said it was for example, there was 16 pages. Do you remember which page it is, on Blackboard or no?
I can find out real quick. If everybody doesn't mind,
yeah, I'm sorry. If you don't have time,
you're
it's fine.
I wanted active questions, so you're good.
Okay.
So let me see. So lecture 4, part 7
Okay.
should be, I think that's where it starts. And then
Okay.
I do it again in lecture 5, or I think I call it lecture 4, part 2. Oh, wait, that is lecture 4. So where am I? Sorry, I'm just trying to find it real quick.
No, it's okay. Take your time.
I believe it's this one here, lecture 5, part 4.
Okay, so 4, 7, and 5, 4.
Yes.
Okay.
Oh, I realized I mislabeled. This is lecture 4, part 2.
Okay.
So under weeks 4 and 5, you should find it.
Okay, so 4, 7, and 5. Okay. All right. Thank you.
Cool. Yep, no problem. All right. So if nobody else has any questions, I'm going to go back to section 8. Sorry, my cat is not usually this vocal. Give me a second. She might want food. Maybe not. She seems to be quiet. Sorry about that. One of the drawbacks of doing this from home is that you have real world interruptions, and my cat is rightfully getting on my nerves, but she's not doing anything wrong. Sorry. Anyway, so who would I rather assign masks? Danny's got comparative advantage in masks, so I'd rather give it to Danny. Okay. Who would I rather assign bottles? Luke's got comparative advantage in bottles, so I'd rather give it to Luke. Okay. And that's the short answer. Give it to the person with the comparative advantage in that good. Okay. This is the longer answer, just kind of talking about the overall reasoning behind it. But the short answer is, if I had comparative advantage in that good, it means I'm more efficient at that good, which means I should be the one to take that part of that labor. Okay. Is that clear?
Yeah.
Yeah.
Cool. All right, so then I want to draw the PPFs. Am I running out of space? Is that a thing in this thing? I thought this was indefinite. So I want to draw the PPF. And there are 3 points I need for the PPF. Three points I need. Sorry, I just want to move this over. So first one, I need x-intercept. 2, I need the y-intercept. And 3, I need the point of complete specialization. Okay. Move this. Okay, and I guess I could label these with, so I have masks on the x-axis, and that's just because I asked you to put it there. There's no economic reason to have masks on one side and bottles on the other. But I'll put bottles on the y-axis. And then I just need these 3 points. Okay. So if I want to find the x-intercept, that is when they spend all their time making masks. When Danny and Luke make only masks. So that'll be Danny makes 48. Luke makes 64. So you add those two up together, you get 112 masks. putting a placeholder here so that I can change it later. Oh, it's right. The y-intercept is the same thing. Y-intercept is going to be Danny and Luke making only bottles. So 120 bottles plus 80 bottles equals 200 bottles. Okay. And then if it was an individual PPF, I would just connect these two lines because I have the x-intercept, I have the y-intercept. But we know that opportunity cost is not going to be constant, right? And the reason it's not going to be constant is at some point, Danny's going to stop making masks and Luke's going to stop making bottles, or sorry, at some point, Danny's going to stop making masks and Luke will start making masks because Danny ran out of time, or vice versa. Danny's going to stop making bottles and Luke's going to, Luke is going to stop making bottles and Danny's going to have to chip in to make bottles, right? So at this point, like when they're both making bottles, that means Danny and Luke are making bottles, right? So if I were to take someone away and have them start making masks, I would want it to be the person with comparative advantage masks. Okay. So it's going to start with Danny making masks. Sorry, I did that slope a little bad. Where did it go? Oh, it's up. I'm just going to change the slope a little bit. Okay. So at some point, they're going to reach a point where going from here to here, Danny can no longer be the only one making masks. Okay. And then at that point, Luke's going to be the one making masks. So this part, the part I've drawn already, Danny's making masks and he's giving up some sort of bottles, some number of bottles in order to make those masks. And what do we call the number of bottles that Danny gives up to make masks? It's Danny's opportunity cost. Okay. Slope is Danny's op cost on just this piece. And that's equal to negative, I believe it was 0.53, well, negative 1.6, I'm sorry. So for this piece, that's poorly, that was stupid. So for this piece, Danny's making masks, he's giving up bottles, so he's giving up a certain number of masks per bottle. And I actually want to be more specific with what I said here. Danny's opportunity cost for masks. Okay. And then there's a point here where Danny makes all the masks and Luke makes all the bottles. And after that, if you're going to this point, they're going to be both making masks. Okay. So from here on, let me just label this guy too. So Danny makes only masks. Luke makes only bottles. And then from here on out, Luke starts making masks. Okay. So when Luke makes masks, he gives up a certain number of bottles. Okay. So this is Luke's slope is, I should say. The slope is Luke's opportunity cost for masks. And that is, negative 1.875. That should be like a brace, like a bracket. Does that make sense so far? So there should be two slopes because at some point, Luke's going to start making masks. And once Danny's done, once he spent all of his time, his opportunity cost no longer matters. Now it's Luke's opportunity cost of masks per bottle, or bottles per mask. Okay. Is that clear? Is that unclear with anybody?
No, it's clear.
All right. If it is unclear, let me know. Like, this is the review session. This is the time to get your questions out. All right. So now we just need this third point, the point of complete specialization, which is this here. That's the point of complete specialization. And that's really easy to do. I'm going to erase that because that's obnoxious. But the point of complete specialization is really easy to do. PCOS, point of complete special, POCS, point of complete specialization. So that's going to be, Danny makes only masks. So Danny makes 48 masks. 48 masks. Luke makes only bottles. Luke makes 120 bottles. Okay. And that's your PPF. That's all there is to it. All right, so hopefully that's clear. Just know that there's going to be two slopes here. And it's always going to be the lower slope first, because if it's not, that means you've assigned comparative advantage incorrectly, right? Because if it's a higher slope, like a higher negative slope, it should be like this and then like that, which we don't want. Okay. So what is the opportunity cost of Luke for making a mask? Oh, I'm sorry, I'll jump back. Label the slopes, what do they signify? I've labeled it. Okay. I think that's everything that I asked for. All right, and then we have this last piece, which admittedly is a little hard. Okay. So I'm going to do this. All right, so assume that they're working alone. I kind of want to write how much they produce again. So Luke did 16 masks per hour and 30 bottles per hour. Danny is 12 masks per hour and 20 bottles per hour. Okay, and then assume they're working alone. Each person must make 50 masks. Each person needs to make 50 masks working alone. Okay. So basically, I want to see how long it takes each person to make 50 masks, how much time do they have left over, and then I multiply that time left over times the rate at which they make bottles. Okay. So Luke needs to make 50 masks at 16 masks per hour. So it takes him 50 divided by 16 hours, which is 3 1/8, 3.125. Oh, that's why I was like, these numbers don't seem familiar. They each need to make 50 bottles working alone. 50 bottles at a rate of 30 bottles per hour. So 50 divided by 30 is 5/3. 5/3 hours that he spends on his requirement for bottles, on bottles. That gives him 4 hours, 4 minus 5/3 hours. On masks. So you can do 4 minus 5/3 times 16 masks per hour. 4 minus 5/3 is 7/3 times 16. So I guess that comes out to 37 1/3. Let's just double check that, make sure I haven't led you guys astray. Equals 7/3 times 16, 37 1/3, perfect. Okay. So 37 1/3 masks. So Luke is 50 bottles, 37 1/3 masks. All right, and then we just do the same thing for Danny. So Danny needs 50 at a rate of 20 per hour. I'm using B for bottles. So he's going to spend 50 divided by 20 hours. So it'll be 4 minus 50 divided by 20 times 12 masks. I mean, 4 hours minus 50 bottles divided by 20 bottles per hour times 12 masks. If you wanted one formula to do it, it's this here. This will get you the number of masks. Okay. So you take 4, your total time, minus 50 bottles divided by 20 bottles per hour, and then you multiply the end result by 12. So 4 minus, it'll be 2.5 times 12 is equal to 1.5 times 12, and that's equal to 18 masks. And of course, he makes 50 bottles. Okay. Did I lose anybody with that?
No.
Cool. All right. Okay, so that's their working alone outcome. 18 masks for Danny, 50 bottles for both, and 37 1/3 masks for Luke. Okay, now assume they can work together. They need to make 100 bottles between the two of them, and as many masks as they can in 4 hours. Okay, so who would you rather assign bottles? Anybody? Bueller? No, nobody?
Can you repeat the question for a second so I can look at my work?
Who would you rather start on bottles?
Danny? Right?
Why?
Because he makes more bottles quicker, or he makes more bottles and less masks than Luke. I don't know if that makes sense.
You're saying he has a lower opportunity cost for bottles. Is that what you're saying?
For masks, he does.
Right. Agreed. So would you rather have him start on the thing he has a higher cost on or the lower cost?
The lower cost?
Right. So Danny should start with masks. Therefore, Luke should start with bottles. Does that make sense?
Yeah.
Okay. So you want to give Luke the thing he has comparative advantage in, which would be bottles. So out of the 100 bottles, we'd rather have Luke working on them.
Yeah.
Cool. Thank you for answering. I know that it put you on the spot, but I appreciate it. All right, so Luke should start with bottles. And again, the reason is because he has comparative advantage in bottles. aka he has lower op cost, aka he makes more bottles per mask. Okay. So there's 100 bottles. Luke makes 30 bottles per hour. So 100 minus 30 divided by, sorry, 5 minus 100, 4. 4 hours minus 100 bottles divided by 30 bottles per hour. The bottles per hour, because you're dividing, the hour will come up top. So it'll just be, the 2 bottles will cancel and you'll have 4 hours minus 100 over 30 hours for what it's worth. Then you're going to multiply that by 16 masks per hour, and that'll get you the number of masks you can make. Okay, so 4 minus 10 over 3, that'll be 2/3 times 16, or 2 to 3 times 16 is going to be 32 over 3 is equal to 10 and 2/3 masks. And he manages to make all 100 bottles. Okay, we could do that step by step. In fact, I never know if it's easier to do it condensed like that or step by step. I think different people have different preferences, so I'll do it both ways. So if I know that he's starting on bottles, and I know that he needs 100 bottles, he makes 30 bottles per hour. It'll take him 3 1/3 hours to make those bottles, giving him 4 minus 3 1/3 hours on masks, aka 2/3 hours on masks. So 2/3 hours times 16 masks per hour equals 32 over 3 masks, aka 10 and 2/3 masks. Okay. That's the long way around it. If like you got a negative number for the number of masks you make, that means that he runs out of time and Danny also needs to help him make masks. Or make bottles, I'm sorry. So if I said like Luke needs to make 150 bottles per hour, then what's in the parentheses will be -1. So that means not only does Luke spend all of his time making bottles, but Danny also has to spend some time making bottles too. All right, so Luke makes 100 bottles and 10 2/3 masks. Danny doesn't need to make any bottles. So 4 hours times 12 masks per hour equals 48 masks, 0 bottles. All right. So that's that part of the question. So if I go up, I would just fill it in 48, 0, 10 2/3, 100. Okay. And then finally, I give you a rate at which they trade. So each bottle is worth 17 over 30 masks. Each bottle is 17 over 30 masks. And they both need to have 50 bottles. Danny needs 50 bottles. Bottles from Luke. So he needs to trade bottles with Luke. He needs to trade specifically 50 bottles times 17/30 masks. This will be mass per bottle. Equals, 1 second, 50 times 17/30, 28 1/3, 28.333 masks in order to get 50 bottles. Okay. Luke needs to trade 50 bottles and receives 28.33 masks. Okay, Luke had 100, 10 2/3. Come on. 10 2/3. And I'm going to add to that negative 50 and 28.33. So I'm taking away 50 bottles and adding 28.33 masks. I guess I should label these here for clarity. 100 bottles, 10 2/3 masks, and he's giving away 50 bottles for 28.33 masks. So he's going to wind up with 50 bottles and 39 masks. Danny had 0, 48, 0 bottles, 48 masks, plus positive 50 bottles is what he receives in the trade, minus 28.33 masks. So he's going to wind up with 50 bottles and 48 minus 28.33 should be 19 2/3, I believe. Equals 48 minus 10.66. Nope, sorry. 28.666. 19 1/3. 19 1/3 masks. Oh, sorry, 2/3. All right. So then the last part is just so that's basically it for A, B, and C. And then D, I just asked you how much would they have made if they did it alone, versus how do they do it when they work together. So when they did it alone, oh, sorry, this is not very clear. All right. So when they did it alone, it was Luke had 50 and 37 1/3. Now he has 50 and 39, so Luke does better. Danny had 18 and 50 bottles, 18 masks. Now he has 50 bottles and 19 2/3 masks. So he does better. So they both do better. And this kind of corresponds to the law of comparative advantage, where basically as long as two different people have different opportunity costs, there exists at least one price where trade is mutually beneficial for both of them. And as long as it's equal to their if the price is equal to their opportunity cost, then it doesn't benefit them, but they don't lose. But the other person benefits, and vice versa if it's equal to the other person's opportunity cost. So if I had like a scale of like op costs, this is DOC, Danny's op cost, and this is LOC, Luke's op cost. Let's say, and this is like masks per bottle, and this is their op cost. Anything in between is mutually, you know what? Mutually beneficial pricing. So as long as the price of masks per bottle is between their opportunity costs, it's beneficial. And then if the price is exactly Luke's op price equals Luke's op cost, mass per bottle, then Luke doesn't benefit. Price equals Danny's op cost. Then Danny doesn't benefit or lose. Luke benefits. Okay. And then like, let's say the price were over here, then basically you're saying that Luke has a higher opportunity, or this is higher than Luke's opportunity cost. So Luke isn't going to want to make that trade. And if the price is here, Danny's not going to want to make that trade. Okay, so they won't make that trade. But there always exists at least one price that will benefit both of them. So essentially, relative to working alone, you can always make somebody better without hurting another person. So trade is going to be Pareto efficient. That's the takeaway. Like wrapping up like lecture 1 to lecture 5, you can get trade to be Pareto efficient. And that's why there's these gains from trade. Because they're working more efficiently, they're productively efficient. And that carries over into Pareto efficiency. Okay. And then with these ones, all you got to do is change the numbers here. So instead of being 28 1/3, it'll be a little bit different. It'll be whatever 50 times 16 over 30 is, and whatever 18 over 30 times 50 is. And then you would just change the answers a little bit. And basically the reason I picked 16 and 18 is because those are the opportunity costs for Danny and Luke. So those examples, so see, like in this case, when it's 16 over 30, it's Luke's opportunity cost. So Luke has the same allocation working alone versus trading. And for 18 over 30, this one and this one are the same. So that's Danny's opportunity cost is the same. Or not that Danny's opportunity cost is the same. The price is the same as Danny's opportunity cost, which means that Danny doesn't benefit or doesn't lose. Okay. So that's pretty much it for quantitative assignment 1, and that's it for the quantitative assignments in general. I'm going to stop here, see if you have any kind of overarching questions, or if this makes all perfect sense.
Yeah, it's all fine, but I have a question on the discussion stuff. That's due tonight.
Sure. Let me just make sure that Naja doesn't have any questions about
Yeah.
the.
Yeah, no, I'm okay.
Okay, perfect. What do you got?
For the discussion thing, we only have to answer one of the 3, or do we have to answer like more than one?
You can answer. So you need 2 paragraphs of answering one question or like one of the topics, and then 1 paragraph twice, like two 1-paragraph responses to one of your peers. They do not need to be in different threads. They do not need to be in the same thread. But you can do it all in one thread if you want.
Okay.
But basically, it's like I ask you to, answer 5 of the 7 questions or 5 of the 8 questions or whatever. You just do that in like a 2-paragraph layout. And then if you want to stick to that thread, you can. If you want to reply to your fellow peers in the other threads, you can do that too. But you don't need to. If you don't want to touch all 3 threads, you don't have to.
Okay.
In fact, it might not even make sense too, because then you have to kind of read different backgrounds and stuff.
Okay.
It depends. Like if you're, I make these threads and I find them interesting to me at least. So I'm hoping that maybe you're interested in all 3. Maybe you're interested in oil pricing and Amazon and Microsoft's competition to be carbon neutral, and also the cost of global warming and policy implications. But that I'm not going to hold it against you if you want to stick to one. I completely understand.
All right.
But you do need to answer within 3. Like there's 3 discussion threads throughout the semester that you'll have to answer before the semester is done. So if you haven't done one yet, you pretty much have to do the next 3 because they're already passed. Yeah, actually, that's a good reminder. I do want to talk a little bit about the course schedule, because I know that people are going to be watching this on the recording. So maybe if you have any questions going on this in general. So we're currently in week 6. So there's a couple assignments that I've posted now. See, as you mentioned, there's a new discussion thread that will last until 10/19, and that's on scarcity, energy, and global warming. So it has a lot to do with externalities and the supply and demand of energy, and how we can internalize externalities and that kind of thing. I like this discussion thread. I put a lot of time into coming up with good questions that I thought would be helpful for you guys in kind of relating what we talked about in the last 2 lectures into the real world, because climate change is a thing that affects you whether you believe it or not. And I don't know, I didn't really, when I was taking microeconomics, I didn't really have too many classes that talked about climate change. And I don't know, I wanted to kind of bring it to the real world. So there you go. The trade review, I highly suggest you do. And the reason I do is, 1, it's a good way to understand how much you understand from quantitative assignment 1. So it's just quantitative assignment 1 with different numbers. 2, you're going to see very similar questions on the midterm as you did in quantitative assignment 1 and this extra credit. And then 3, it's 2 points to your final grade. So there's a high reward. The opportunity cost is really low because the answers for quantitative assignment are already up. Plus, we just talked about them in depth. So you should be able to kind of breeze through it, and it'll just reinforce what you need to know for midterm 2 or midterm 1. So I highly suggest you do it. It is due on Thursday, so not a whole lot of turnaround, but that's so that I give you extra time. I don't want people focusing on the extra credit at the expense of the midterm. So that's up there now, if you want to do it. The textbook assignments also do 10/8. It covers 2 chapters. Shouldn't be too bad. I hope that those textbook assignments, I hope you guys aren't finding too exhaustive, right? They're not they're not like killing you for time, right?
No, I think they're fine.
We're pretty much required to do them. And I do like them, but I don't want them to be like the focus of the course. It's just kind of just supplementing the real world knowledge you get from, because the lectures I feel like are really high level, pet examples, like things that are really simplified, but that I want you to get the math on, but then I also want you to be able to relate things to the real world, so I keep the textbook assignments there. Obviously, midterm 2 is next week. It's going to be take home. You'll have 3 days to do it. It's due 10:15 at 11:59 p.m. and I'll be posting it on 10/12. Obviously, there's not going to be another lecture today because this is the lecture, and this will be posted on Blackboard for everybody to watch if they want to watch it. The immigration assignment's closed. This is closed. Everybody had a chance to revise their textbook assignments 1, 2, and 3. Otherwise, there's not too much coming up. It's just the extra credit, the review if you want to do that, and then the textbook assignment. And then I kind of wanted to give you some time to study for midterm 1. Yeah, and then I wanted to have everything graded by today, and I'm really sorry that I haven't graded everything. It's just a beast. This class is very time consuming. But I should be finished quantitative assignment 1 at least by today. Quantitative assignment 2 is obviously not due until the end of the day, so that won't be graded today. And then I'll probably get through the textbook assignments tomorrow because they shouldn't be too bad. And then there's only like 3 commanding heights. So people who did commanding heights should be tomorrow or Wednesday, I'm hoping. Trying not to make promises, but I'm doing my best. Okay. If there's no questions about the schedule, I want to go through the review session PowerPoint. And, I don't want to go too long on this. It shouldn't be too bad. But if you guys have questions, feel free to stop me. And then if we cut off at 9, you guys have places to go. I don't want to keep you longer. I think 3 hours is more than enough time for this review session. But if you guys want to stick around, I'm happy to go through in more depth, depending on what you guys want to do. All right. So no questions on the course schedule?
No, I don't have any questions.
Cool. All right. And just a reminder for the people who are listening, you can drop 2 quantitative assignments. One of the midterms is dropped, or the midterm or final, whichever is the lowest scoring thing. The reading assignments you need to do, discussions, just pick 3, but at this point, if you haven't done one, you need to do them. And then journals, pick 2, and then if you do 3 more, you get extra credit for any of the 3 that you do. And then there's still 3 more extra credit assignments in addition. And then on top of that, I do curve the class at the end of the semester. So if you're like fretting about grades, just know that what you see on Blackboard, it's out of 272. That is not my calculation. There's nothing, there should be no reason that there's out of 272. That's just, the McGraw-Hill assignments are like 150 and 110, and then the rest of it is like 2%. The 272 means nothing. If you want to calculate your final grade to this point, the 3 textbook assignments are worth 3% each. So if you did those, you should be getting 2 to 3%, depending on how well you did on those. Provided you're not dropping quantitative assignment 1, that should be 8%, and same thing with quantitative assignment 2. But if you haven't done them, you can drop them. Just make sure you do the other 3. And then, your journals, nothing's counted yet, but you can do, if you can count those as being 4%, is up for grabs. And then the other 3 will be up for grabs if you want to grab extra credit. And then, discussion threads, you can, like, if you've done one discussion thread and you're like, I don't like my grade, which I think everybody got 3% for the first discussion thread or whatever it's worth. But if you want to do the best of your discussion threads, just keep posting them. There's no real opportunity cost. or besides your opportunity cost of time, there's no opportunity cost. Okay, but there's nothing to be gained if you got max points on all three of those. Yeah. So don't fret about your grades. Everybody who's handing in the assignments is doing well. If you're not handing in the assignments, make sure you start, because at some point you can't drop any more quantitative assignments. Okay, that's my disclaimer. Cool. If you're wondering why things are zeroed out, is because you plagiarized. I don't think either of you guys are plagiarizers, but if you're like, oh, why is textbook assignment 1 zeroed out, is because you plagiarized on it. You should have failed the course. I took much clemency on that. But you even had an opportunity to revise it. So those assignments are not graded yet. If you redid them, you have an opportunity to revise it. Don't expect leniency going forward, because that is very uncharacteristic of me. Okay. Sorry for you two. I'm not giving you guys, this disclaimer is meant for the people who are watching this lecture, not for you two in particular. I just want that to be clear. I'm not chastising you guys. Yeah. Okay. So I had these review slides up in week 6, and there's a lot here. So we probably won't get through everything by 9 if you guys want to cut off. But the answers are all up there, so you can kind of walk through it yourself. And if you're like, oh, this makes no sense to me, let me know. I'm happy to schedule more time if you guys want to talk about it. Okay. So just what you're responsible for the midterm. I'm even going to bring the midterm over real quick. And I'm going to zoom right through it so you guys don't see too much of it. And this is just last year's midterm. I'm going to revise it. But essentially, there's going to be some short answer questions, some trade questions, some more trade questions, and then some supply and demand questions, consumer surplus, supply shifters, demand shifters, that kind of thing. There's probably going to be Pareto efficiency questions that I haven't written on here. Probably going to be something about comparative advantage. I'm not exactly sure. That was just my last year's midterm. So you can use that as a base, but the actual framework of the midterm will be similar, but the questions will obviously be different. Okay, so what you're responsible for. You're responsible for the 2 quantitative assignments to this date. So from homework 1, you want to know your production possibilities frontier. You want to know gains and trade, opportunity cost, comparative, and absolute advantage. So your production possibilities frontier would be like the Danny and Luke. They each had that, where'd it go? Oh, sorry. So the production possibilities frontier could be the individual PPFs, where you just need to find the intercepts and then the slope and label the axes. The joint PPF, where you also need to find the point of complete specialization, and there will be 2 slopes. Gains from trade is what happens when you divide up the labor based on comparative advantage. You get some sort of extra product. So Luke and Danny both were able to make more masks working together than they were working alone. That's your gains from trade. Opportunity cost is the foregone alternative. So by virtue of not making masks, by virtue of making masks, you're not making a certain number of bottles. Opportunity cost might also be framed in the sense of like the utility you get from a choice that you made, or from the choice that you didn't make, rather. So if I have 2 bowls of cereal, and one cereal gives me 10 utility, one cereal gives me 8 utility, and I choose the one that gives me 10, my opportunity cost will be the utility from the cereal that I didn't eat, the 8 utility over here. Okay. Comparative advantage basically means you're able to do things more efficiently, so you're able to make more masks per bottle. That means you have comparative advantage in masks. Alternatively said, you have a lower opportunity cost of masks. So you always want to give the person who has comparative advantage, you want to start them off with the thing that they have comparative advantage in. Absolute advantage just means you're able to make more masks per hour or make more bottles per hour. You just have absolute advantage in masks. or absolute advantage in bottles. Okay, you always want to divide your work up based on comparative advantage, not absolute advantage. For the same reason, even if Michael Jordan could sweep the Chicago Bulls stadium faster than a janitor, he should still be out there on the court making, playing the game instead of cleaning up the stadium. Okay. Okay. From homework 2, what do you need to know? Consumer and producer surplus. I want you to understand it for both discrete and continuous terms. So discrete would be like when we did the, so in quantitative assignment 2, the discrete one will be like this one here, where we had the graph as a stair stepper when there's only a few people and they were only consuming a few goods. And then the discrete one would be the general one where you have a lot of people consuming fractional goods and whatever, and that'll just be the area between for consumer surplus, it'll be the area between the demand curve and equilibrium price, and for producer surplus, it'll be the area between the supply curve and equilibrium price. Okay, so be able to calculate that for both. So for discrete terms, you're just adding up the individual consumer surpluses. So you'll take Donna's consumer surplus plus Whitney's consumer surplus plus Tina's consumer surplus. For continuous, it's just going to be this area here. So it'll be the area of a triangle. So it'd be different depending on whether it's a stair stepper or not. And I'll let you know if I want you to do a discrete graph versus a continuous graph. Is that clear, the way that I phrased that? And the distinction between discrete and continuous graphing?
Yeah.
Okay. Okay. All right. So be able to calculate consumer and producer surplus. That'll be the Whitney Donna question if it's discrete, or the peanut butter question if it's continuous. I want you to identify Pareto efficient allocations. So that'll be the last question from quantitative assignment 2. It's also a couple times in the lectures. Also, it's going to be the back end of this slide deck here. I have like 5 or 6 examples for you to go through if you want to do it on your own. Plotting and shifting supply and demand curves. So that'll be your peanut butter questions. Like, so basically, can you, given an equation, can you plot the graph, like the line there? And then if I give you a supply or demand shifter, do you know if it goes outwards or inwards? Also, I want you to, just like with the Whitney Donna Tina problem, if I give you a certain number of willingness to pays, so if I say that they're willing to pay $1 for the first shot, 50 cents for the second, 25 cents for the third, you should be able to map that to a demand schedule and then be able to map that to a demand function. Okay. And then finding equilibria. So given that you have a supply curve and a demand curve, can you solve the system of linear equations and find the intersection between price and quantity? Okay. So the intersection of the demand and supply, where you have one equilibria. Okay. So hopefully that's all clear. Basically, that's just the stuff that we just spent the last 2.5 hours going over. Nothing that I just said would have been outside of the framework of that. Okay. In addition, there are some vocab words on the slides that I hope that you know. You don't necessarily need to know them verbatim. I don't expect you to remember all the definitions, but be able to understand the concepts. And if I give you a short answer question, be able to talk about them the way that I would have in lecture, the way that they are in the slides. Okay. So agents, for example, an agent would be, Riggedy Rowe and Stankonia in the Hawk and Dove game. Those are the players of the game. The recruiter and the job seeker in the signaling model, or the USFL, NFL in that model, Marshall and Kendrick, Luke and Danny, they're all different agents in different scenarios. You can even say producers and consumers are the agents in the supply and demand model. Okay. So agents are basically the people that are making the decisions in the different frameworks that we look at. Utility, that's just a way of ranking how the agents prefer things. So utility is usually a number or variable that we use to rank different choices. So I get more utility from consuming more hot dogs than less hot dogs. So I prefer more hot dogs to less hot dogs. Okay, it's that simple. And like the Hawk and Dove model, I give different utilities for different actions. And all it is a way to rank things so that you're able to say something coherent about the choices that the agents are faced with. One thing that I guess I don't mention here, which I guess I don't have a test on, but it's not in the test, but it is important. And I do talk about it a lot in lecture. So let's say this is hot dogs. Okay. And this is my utility from hot dogs. In general, economists make the assumption that as I consume more hot dogs, well, they make this about any good that you like. As I consume more of that good, my utility increases. But my marginal utility, the utility I get from the second hot dog versus the first hot dog, or from the third hot dog versus the second hot dog, is actually going down. So even though I prefer consuming 3 hot dogs to 2 hot dogs, my overall utility is increasing. The additional utility I get from consuming the third hot dog is lower than the additional utility I got from consuming the second hot dog, right? Basically, even though more of a good thing is good, it's not as good as the first unit of that good thing. $100 to someone who has no money is a lot of money to them. $100 to Bill Gates is not even registering. That is, he'll never notice. So someone who's getting their first $100 is going to see a massive utility jump. Someone who's getting their billionth $100 is going to see a negligible jump in utility, even though they would see an increase in utility. So that's just a thing that I don't think it's going to show up on the test, but it is an important thing that I did cover that I just wanted to kind of make a brief point about. I guess I'm stuck with this guy here. Just a regular arrow. All right. Next up, willingness to pay. That's just a way of ranking your utility in terms of dollars. So if I say you're willing to pay $10 for a hot dog, that means that your utility from that hot dog is equal to the utility you get from $10. And utility or willingness to pay basically correlates pretty closely with your demand curve, where the underlying willingness to pay will be able to generate a demand schedule, which then you can generate a demand curve with. So if I say the price is $6 and 5 people buy, you could say that 5 people are willing to pay $6 for that good. Also, willingness to pay relates to the demand curve in the sense of individual consumer surplus is willingness to pay minus the price paid, and total consumer surplus is the demand curve, which tracks directly the willingness to pay minus the price paid, but for every consumer, so it'll be the area between the demand curve and the price paid. I want you to know the distinction between macroeconomics and microeconomics, where macroeconomics is the bigger picture economics problem, usually relating to things on aggregate, things that you take an individual household and you blow it up as representing the total economy for every household. And you'll see kind of overall growth for the economy for a country, or overall growth country versus country, or inflation. They're all typically macro problems, whereas micro tends to look at individuals, it looks at individual households. It looks at, maybe one country, one market, or a few different players in one market, something like that. So micro is typically smaller picture, but you tend to look at it more focused like a microscope. So if I ask like how Amazon and Uber are competing, that would be a micro question. If I ask how the United States and China are growing relative to each other, that would probably be a macro question. Next up is abstraction, which is just the kind of the assumptions you make in order to say something definitive about a model. So if you want to say something worth anything, like if you want to make a conclusion that's coherent about a model, you need to make some sort of abstractions. So if I give you an economic problem like how are minimum wages affecting overall unemployment, there's a million things that could go into that. I want you to be able to distill it into its key elements and just say the things that are important to that model. And by doing so, you're able to generate, a series of mathematical equations, an actual model, and you're able to get like a relationship on those things so that you can apply those mathematical equations to logic. So if we're looking at the Luke and Danny problem, for instance, it's actually lower. If we're looking at the Luke and Danny problem, right, this is a highly abstracted model where I make very, very many assumptions basically about their production patterns. Basically, they're fixed production patterns, 16 masks, 30 bottles per hour or whatever. They're not changing. They're not dependent on the underlying production patterns of the country where the resources matter or the supply chain matters, because trade is really complicated. It's a really complicated topic. But no, I'm looking at two people within a country, and they're producing only two goods. So, abstracting away from the millions of other goods that they could produce and the different ways in which production is not, a straight line. It's not 30 bottles per hour. So it's highly abstracted. And if this was your overarching model, I'd say it's a pretty bad model. But it does say something meaningful in that we were able to solve it very quickly, or depending on the person, once you understand it, you're able to solve it pretty quickly and say something meaningful about the fact that there are gains from trade, what the production patterns end up looking like, who has comparative advantage and what their opportunity costs are. You're able to say a ton of things about this model because you've made a lot of abstractions. In real economics, I would hope that a good economist makes less abstractions and has a little bit more detail in their models than this. But even great economists are still going to be making a fair deal of assumptions and abstractions about the model in order to say something that's doable, in order to say something meaningful about the pattern of opportunity cost and the pattern of comparative advantage and who produces what and how much of a particular good is being produced. So all that's to say, abstraction is taking the key elements, no more, no less, and using it to say something useful about a particular economic problem. And then positive and normative questions. A positive question is basically an is statement, a truth statement, something that can be verified. It doesn't have to be true, but it's something that can either be shown as true or false. A normative statement is essentially a matter of opinion, something that will never truly be able to be said as true or false. So I like the movie Goodfellas. If I said more people should watch Goodfellas, that is a normative statement. If you said Goodfellas won the Oscar in 1991, I don't know if that's true or not, but you could look it up and you'd say, oh, that is a false statement, but it's still a positive claim in that it's falsifiable. Whereas I like Goodfellas is a true statement, but you should like Goodfellas is a normative statement. Whether you should or should not is really up to opinion. And economics tends to restrict itself to positive statements, things that are in some fashion or another, you can show evidence to show that they're more true or more false. and you can claim that, oh, this evidence is bad, this evidence is better, but at the end of the day, you're making a claim about how true a statement is. We can use that, and that's what economists will restrict them to inform policy. So if you have a truth statement and you believe it's true and you have evidence to show that it's true, that will inform whether you want to impact a particular policy or not. But some policies are more or less based around your philosophy and what you think of as normative. So someone might want to make a statement about fairness, like health, like having access to healthcare is a fair thing to do. Economists should really restrict themselves to say we can provide healthcare efficiently or inefficiently, or we could provide healthcare to more people or less people, and this was the cost and whatever. Economists should not say healthcare is a fair thing to do. That is a normative claim, and it's something that we can help people make a decision about. But at the end of the day, fairness is not is more of a philosophical question than an economist question. Okay. Models I kind of talk about a lot in that one lecture, but it's just a way of using an abstraction to represent something logically and mathematically, represent different relationships, and then you're able to use that model to say something about the real world. So it's a distillation of the real world into a set of basically mathematical or logical steps, so we can say something about how the world works given a certain number of abstractions. Okay, and then the law of supply and demand. So the law of supply says that the supply function should always be positive, because if I'm a producer and I can get more money for a particular thing that I'm selling, I would rather sell it. So the more people want to sell, the higher the price is. And then law of demand is the opposite. The higher the price is, the less people want to demand a particular good. So the demand function should be sloping downwards. And that's true for virtually every good. So there is a very, very theoretical, basically, type of good that has an upward sloping demand function that we don't really want to worry about in this class. Okay. This is actually a good stopping point if you guys want to jump off. I have a series of questions that I can go through. I'm going to restrict it to 30 minutes. I don't want to go till 10 o'clock. But that's kind of what you need to know. And then the rest is just practice if you want to go over it. If not, feel free to stop off. I'm going to continue talking either way. Do you have any questions to this point?
No.
No, but I think I'm gonna hop off.
All right. Have a good week.
Thank you.
I won't see you next
too.
week, or I guess I never see you, but next week is the midterm, just as a reminder. So make sure you keep, some time between 10:12 and 10:15 open.
Okay, thank you.
Yep.
All right. Thank you.
Yep. Are you heading off too, Anaja?
Yes.
All right. Have a good week, both of y'all.
Bye.
You too. Have a good night.
Good night. All right, so it's just me. I'm going to go over the answers to the slides really quickly. So this is a game I created based on Reddit, just different hot takes. And I want you to determine whether or not they're positive or normative questions. So let's just start. And then I do ask that you come up with a corollary normative question based on that. Movie critics are useless, and the reviews shouldn't be taken seriously. So I might give in that the first half, movie critics are useless, is maybe technically a positive question, but I still think it's more normative question, because what does it mean to have use? But the second part is definitely a normative question. The word should is usually an indicator that it's normative. But basically, this is just some jabroni's opinion about movie critics. It's not making a factual claim. That can be proven true or false. So I consider this a normative question. A corollary positive question might be like, movie critics are out of touch because given the number of Academy Award winners versus the amount of money made in the box office, critics are not good at predicting what people actually like. That would be a corollary positive question that can be shown true or false. Next up, one of the biggest failings of modern education is managing to convince a whole generation that Wikipedia is an unreliable source. I consider this a positive question. When I give you these questions on the midterm, they'll be kind of more definitive. I am based on opinions here. This is an opinions-based subreddit. Anyway, one of the biggest failings of the modern education system is the manage to convince a whole generation that Wikipedia is an unreliable source. This is something for which you can provide definitive evidence of. You can provide evidence that the modern education does convince them that Wikipedia is unreliable. You can provide evidence that Wikipedia is reliable, or you could provide evidence that that given that the education system is saying that it's unreliable, that is providing, you can do like a cost analysis of what that would look like. That is, to me, a very positive question. Even though it's still kind of an opinion, it's something that's true or false, falsifiable. You can provide evidence of it. I would say like a corollary normative opinion would be like, Wikipedia should be used as a reliable source. Next up, making fun of men who lose their hair because of male pattern baldness is body shaming. I consider this a positive question. If you have a definition of body shaming, let's say body shaming is the shaming of a body, and you can say, A, body shaming is the shaming of a body, B, hair is part of the body, C, making fun of someone is shaming. Given A, B, and C, necessarily, you are body shaming. Given that you are making fun of a body part, you are, given that making fun of someone is shaming, and given those things, making fun of a person is body shaming. That is a true or false statement. If you can disagree on the definition of what body shaming means, but if you pulled out the dictionary and you came up with A, B, C, this is what it means. This is what the claim is. Given that this is body shaming, it follows from the logic in the same way that any logical claim would. So that to me is a positive claim. Corresponding normative claim would be you shouldn't make fun of people with male pattern baldness, which is absolutely something that you should not do. I'm proof in the pudding. If you make fun of male pattern baldness, you're losing 5 points on your midterm. Just kidding. But no. Next up, sleeping in your car should be completely legal and never looked down upon. That is completely normative. It is an opinion. It is a should statement. You could provide evidence that it's safe or whatever, but then you're kind of changing around what the opinion is. You're changing around what Dank Mean King 21 was trying to say. Okay. So a corresponding positive claim would be it is safe to sleep in your car given the relative crime rate or the relative murder rate of people who sleep in their car, or it's your property, and you're entitled to certain constitutional rights within your property. So therefore, sleeping in your car is actually technically legal, or by the definition of whatever the 4th or 14th Amendment, you should be able to sleep in your car. That would be more more positive than what it says right now. Okay, and last up, YouTube and the internet as a whole was much better when people were creating content as a hobby instead of a job. This is kind of middle ground. Better is, to me, an opinion. But also, you could kind of provide evidence of like views per click, or like enjoyment per click or utility per click. But overall, I would say this is a normative claim. And now I'm nervous that I might have put positive because it is kind of trying to make a truth claim. But I think better is the key thing here, because what makes something good is really up to philosophy. It's not really an economics claim. In the same way that fairness is a philosophical claim. So I think this is more normative than it is something that's like empirically shown. So the corollary positive statement would be YouTube before the rise of the influencer had higher content absorption. It had higher people stayed on the particular video for a longer time or something like that. Okay. So normative, positive, positive, normative, normative. All right. Next up, I have some micro and macro questions. These are topics I pulled from headlines. Some of these are from podcasts I listen to. Some of these are from the Wall Street Journal or Forbes or something like that. And I just want you to determine, do these headlines correspond to micro or macro questions? All right, so first up, egg prices. The price of eggs have skyrocketed at the start of the pandemic. That has some people crying foul, haha, good pun, NPR, good job, terrible pun. So anyway, that is a micro-based article, or podcast, I should say. You're looking at pretty much the supply and demand of one market, which is something you'll see a lot of here, and have seen at this point already. So that is a micro question. Okay, it's one market. You're not looking at prices for the whole country. Okay. Next up, I have grocery store wars. The profit margins for groceries is razor thin. To stay competitive, Amazon Prime is introducing a new service. That's also a micro question. Essentially, you have one industry, and you're looking at one firm within one industry, but implicitly you're looking at a couple firms within the industry because they're competing against each other. But basically, one firm is introducing a new good to that industry, so that should be one firm micro. Okay, one firm competing in one industry is micro. General Mills is desperate to keep up its growth, so it's making up new foods. Again, that's pretty much the same thing. It's growth, but it's one firm's growth, so that should be a micro question. All right, rich economies set to recover more quickly from COVID-19 contractions. All right, so you have a global economic story here. That should be your key. You're talking about many countries. This is a tried and true macro story. Okay, next up, more job growth, but slower. You're talking about unemployment numbers for the country. So this is pretty much a tried and true macro question. It's talking about the whole country's growth. So that should be a macro question. You could have micro labor questions, but this isn't really one of them. So I would consider that macro. Micro labor would probably be like the labor market in one particular industry, essentially. Or like for particular individuals, not for the country as a whole. And then lastly, this is an article about inflation. Inflation is always going to be macro because it's talking about the price level for the country as a whole. Okay. So I had 3 micro, 3 macro. All right, so next up I have an example of a model. So this is a model that is actually, I obviously made it Philadelphia based, but this is a legit game theory model. I just made it cooler. So imagine you have 100 people in West Philly that all equally want to go to Patty's Pub. If 60 try to go at the same time, the pub will shut down, no one will be let in, and the people who go will be angry for having made the journey. If 59 or less people go, everybody has a good time. So basically, it's like, if you think that you're going to be the 61st person, you're not going to want to go. But if you think you're going to be the 59th person, you're going to want to go. Okay. So like, you don't want to go if you think everybody else is going, but you do want to go if you think that nobody else is going, or that a few people are going. Okay. So who are the agents? The agents are the people who, of the 100 people. There are 100 people who have the ability to make a decision about going to the bar or not. Patty's, I would not say, is an agent, and the reason that they're not an agent is because they're not doing anything. They don't have any choice in the matter. Basically, they're like the setting of the problem. They're not making any real choices. It's if 60 people go, they shut down, or yeah, if 60 people go, they shut down. If less than 60 people go, they stay in business. Nobody's really, Patty's Pub is not really making any choices in the matter. Okay. What are the objectives of the agents? They're trying to have a good time. The agents are trying to maximize their utility by determining whether they should go to the bar or not. Obviously, they want to go to a bar, but if too many people go to the bar, they don't want to do that. Okay, rank their utilities. Going to the bar when it's not at capacity, going to a bar when it's at capacity, staying home. Okay, so if a bar is not at capacity, I'd rather go. So that should be number one. If the bar is at capacity, I'd rather stay at home. So that should be the last. And if the bar is at capacity, I'd rather stay at home. So like, if I know the bar is not at capacity, I want to go. If I know that the bar is at capacity, I'd rather stay at home. So it should be A, C, B. Going to the bar not at capacity beats staying at home, which beats going to the bar when it's at capacity. If I'm willing to pay $0 to stay at home, would I be willing to pay more than $0 to go to the pub if I think no one is there? Yes. So if I'm more willing to go to the bar when it's not at capacity than to stay at home, then my willingness to pay to go to the bar should be higher than my willingness to pay to stay at home, given that I know that I'm not going to be turned away. Okay, willingness to pay is a way to rank, or a way to measure utility. And your utility is a ranking of your three options. So we said that A is greater than C. I'd rather go to the bar when it's not at capacity than stay at home. So my willingness to pay for A must be greater than my willingness to pay for C. My willingness to pay for C is 0, so my willingness to pay for A should be higher than 0. Why would you be angry about going to the bar and getting turned away versus just staying at home? Well, in the real world, why would you be angry? I'd be angry because I made the trip out there. Okay, I paid for an Uber or whatever. I biked over there because it's COVID and I can't take an Uber. I biked over there. It cost me 30 minutes of my time, and I had to bike back for another 30 minutes. And I would have made plans if I knew that I was going to be turned away. What is all of that? That's my opportunity cost. So I incurred this opportunity cost of going to the bar and having made plans. And what did I get from it? I got nothing. I got no utility cost, or no utility, but I paid an opportunity cost. So that's why I'm pissed off. That's why I'm angry. Okay. Versus staying at home, which, yeah, there's an opportunity cost of staying at home if the bar's not at capacity. But if the bar's at capacity, my opportunity cost is negative. So I'd rather just stay at home than not. So staying at home is the best case scenario there. Okay, so I'm incurring an opportunity cost when I go to the bar and get turned away. What are some abstractions in the model? Well, first and foremost, you're abstracting that, each person is making the decision at the same time, that there's no like line for the model. Like if I'm the 60th person, Patty's Pub isn't just going to line me up and wait for someone to leave. You're abstracting that Patty's Pub is going to make a very linear choice, that they're going to say at 60, boom, everybody out. Not like at 60, the 60 people who were there can stay, right? And then the other people can wait. You're making a choice, or you're making an abstraction that there's only 100 people. Yeah, those are a few of the abstractions. There might be more. Okay. Oh, you're making an abstraction that everybody has the same preferences. So maybe someone has a preference that, I want to go to the bar, but only if it's like really socially distant, if it's at like 15% capacity or something like that. Otherwise, I'd rather just stay at home. So they might make a different decision than the other 99 or something like that. So that's an abstraction that all 100 people are playing or essentially have the same preference structure. Okay. So we have a map here, and this is a map of different exports for each country. And I just want to kind of like run through the comparative advantage kind of questions, but this time, instead of having the quantitative focus, let's do it all qualitatively, okay? That way you're kind of like thinking about it, not just in the math, but in terms of the real world. So this is a list of all the countries and their exports. And obviously the real world is a little murkier than the comparative advantage model that I showed you, because that was highly abstracted. But more or less, you are saying something relevant about the real world, and we'll talk about that now. Okay, so relative to Canada, who has a comparative advantage in cars? So what I would do is I would look here. I'd see, okay, well, Mexico is exporting cars. Why would Mexico want to export cars? They want to export cars because that's probably where they specialize in, right? When you have two people trading a certain thing, you can say that they're trading that thing, provided that they're acting efficiently. They're trading that thing because they have comparative advantage in that thing. Okay, so Mexico should specialize in cars because they have comparative advantage in cars. That's not to say that these other countries here might not have comparative advantage in cars relative to Canada. We just can't say for sure that they do, just based on what we're looking at here, where everybody else has something else. Okay, so relative to Canada, we can say for sure that Mexico has comparative advantage in cars, provided that they're acting efficiently. Okay, what determines who has comparative advantage in each good? So essentially, you have comparative advantage if you have a lower opportunity cost for that good. So Mexico makes more cars per unit of petroleum than Canada does. So that's why Mexico has a lower opportunity cost for cars, and they have comparative advantage in cars. Likewise, you could say the flip side for petroleum for Canada. In the real world, what determines who has comparative advantage usually has to do with their relative resource abundance. So Mexico might have more of the materials needed to make cars, for instance, more labor or cheaper labor than Canada does. Okay, whereas Canada has a vast system of oil, like a vast reserves of oil, so that's why they're able to produce more petroleum than Mexico does, where Mexico probably doesn't have too much oil. Okay. If the U.S. makes more cars than Mexico, can you say for sure if it has comparative advantage in cars? So this is a kind of it's not a trick question. It's a very important question. But you cannot. The reason you cannot is because, I'm sorry, this is comparative advantage. No, so still you cannot. If the U.S. can make more cars than Mexico, we know about its absolute advantage. Okay, So we can't say for sure that it has comparative advantage in cars. And if we're looking at this particular graph, we could pretty much say for sure that the US does not have comparative advantage in cars, just because of what we're looking at here says that Mexico is exporting cars to the United States. Okay, so no, just because the US has more cars than Mexico does not mean that they have comparative advantage. It does mean that they have absolute advantage, which would be the next question. Okay, and looking at the graph with the additional information, we can say that the US does not have comparative advantage in cars. How would the US trade with Mexico if the US can make more cars than Mexico? Okay, also an absolute advantage question, right? The US probably can make more cars than Mexico, but they would still rather trade petroleum for cars because that's where their relative comparative advantage lies. Okay, so you always want to trade based on comparative advantage, not absolute advantage. If the US trades with Mexico, does the US benefit? Does Mexico benefit? Okay, they will always benefit as long as the price is between their opportunity costs. And I'm not going to belabor this point because I already talked about this a couple times, but if the price lies somewhere in between their opportunity costs, then they will always benefit. If the price lies exactly on their opportunity costs, then one country benefits and the other does not lose, and vice versa. So if the trade of petroleum per cars was exactly equal to the US's opportunity cost for petroleum per cars, then the US wouldn't want to trade. Or sorry, they would want to trade, or they would be indifferent to trading, and Mexico would want to trade. And in the real world, that matters because, for instance, right now, probably the United States is trading at a rate that is closer to its own opportunity costs with Mexico for cars, based on like the terms of NAFTA. And Mexico is seeing a lot of gains from NAFTA. The United States is seeing gains, but it's less gains than Mexico is seeing. And as we'll see in the next couple questions, the gains come at a cost. So even though overall it's more effective, more productive, there are some costs to certain people. Okay, but overall, yes, the U.S. does benefit from trading with Mexico, as long as its opportunity costs is not exactly equal to the price of petroleum per cars. Okay. If the U.S. trades with Mexico, what will it trade and why? It will trade petroleum because that's where it has its comparative advantage, and it will trade petroleum in exchange for cars. Will petroleum producers in the United States be happy to trade with Mexico? I would. You're trading more petroleum. So the United States is basically specializing in petroleum, so they're producing more petroleum, the same way that Luke was specializing in bottles, so they produce more bottles. This means that petroleum producers in the United States are happy. Petroleum producers in Mexico are less happy because what little petroleum producers there might have been are probably decreasing in size. Okay, so yes, the U.S. petroleum producers would be happy. Assuming American car manufacturers have no ownership in Mexico manufacturing plants, will car manufacturers be happy to trade with Mexico? I wouldn't be. So if my entire plant was in the United States and I saw no benefit from Mexican manufacturing, I wouldn't want to trade. I would want all Americans to buy American cars. I would not want Americans to specialize in petroleum and therefore shift away from producing cars. Okay. So in the same way that when Luke specialized in bottles, he produced less masks. When America specialized in petroleum, they're producing less cars. This is bad for car manufacturers. In the real world, though, what ends up happening is like the higher-ups, management in the manufacturing company are probably doing all right. And the reason they're doing all right is because the cars that are being manufactured in Mexico are still GM cars, they're still Ford cars or whatever. They're still American cars. They're just being produced in Mexico. So what happens is the management in Ford is doing fine. The people working the production line in Ford are not doing fine. Okay. And that goes to the next question. And sorry, the next point is Mexican car manufacturers. So people in the production lines in Mexico are happy with this trade paradigm. Okay. All right. Second to last point: if manufacturing a car takes more labor than capital, will people working in GM factories in Detroit be happy? No, for the reason I just said. There's more labor than capital in manufacturing cars. So basically, we're shifting away from producing labor and we are shifting more into producing petroleum, which is more capital intensive. So individual workers, the people working the production line, are very unhappy because they're losing jobs and it's not being adequately replaced in petroleum because petroleum is more capital intensive. So people who are producing petroleum, like the individuals producing petroleum, are less than the individual laborers who are producing cars. So there's less jobs to go around, but more money to be made per job. So it's bad for individual workers because they're probably losing jobs to Mexican workers. Okay. What range of prices will America and Mexico be willing to accept for the trade? Anything between their opportunity costs, up to and including their opportunity costs. Per the law of comparative advantage, as long as two different countries have different opportunity costs, there exists at least one price that will benefit both countries, and if you trade exactly at their opportunity cost, it will benefit one country and not hurt the other. So that's the real world. In the real world, just because there's gains from trade between trading petroleum and cars, it matters. The price matters. So if the price is too close to one country's opportunity cost, the gains from trade are unequally distributed, and that depends on like the trade deal, the individual trade deal that you have. And then even if you have a good trade deal, even if the price is equal to the other person's opportunity cost, so you're seeing all the gains from trade, for a particular industry, that might still suck if you're specializing away from that industry and into the other industry. And in the real world, like if I'm working in a car plant my entire life, I don't necessarily want to switch over to working in petroleum. 40 years in my career, that's tough for me. So there are costs and benefits, even though there's overall gains from trade. And I don't want to say what's better or worse because it's to some degree normative and some degree a policy question, and it's just a matter of getting the right policies and the right deals and kind of subsidizing or not subsidizing, depending on what you think industry will last, or coming up with some sort of social safety net or not. That's all beyond the scope of this course. But you can say it's more efficient to trade, even if there's an equity trade-off, even if there's some sort of fairness trade-off. All right, so that's that. So for more on trade, look at quantitative assignment 1 again, the extra credit assignment in journal 2. All right, tell me if a good is a substitute or a complement. As a reminder, a substitute is a good that when its price increases, the demand shifts out for the other good. A good is a complement, and when its price increases, the demand shifts in. So two goods that go together are complements, two goods that compete are substitutes. Okay, and a complement, I'll talk about it. Okay, so Dunkin' Donuts bagels and Wawa bagels should compete, so those should be substitutes. So when a Wawa bagel increases its price, Dunkin' Donuts should see a spike in demand. Okay, Dunkin' Donuts bagels and Dunkin' Donuts coffee, those should be complements. I would go to Dunkin' Donuts. I might buy both at the same time. So if Dunkin' Donuts raised its price of coffee, I might go to Starbucks. So Dunkin' Donuts bagels, even though their prices didn't change, should see a decrease in demand. Netflix and Amazon Prime. So Netflix and Amazon Prime are substitutes. If Amazon Prime increases its price, I would consume more Netflix. I would be more likely to subscribe to Netflix. Okay. Netflix and Comcast cable should also be substitutes. There's the idea of the cord cutter. The cheaper that Netflix gets, the less and less subscribers to Comcast cable there are. Netflix and Comcast internet, on the other hand, though, you need internet in order to run Comcast, or in order to run Netflix. So I would think that those two things are complements. So the more expensive that internet becomes, if the internet is now $1,000, you might not see too many Netflix subscribers because people are going to be scraping by to get their internet. And lastly, Comcast Internet and Verizon Fios. Those should be competitors, so they're substitutes. And if Verizon Fios increases its prices, Comcast Internet should see a spike in demand. Okay, normal or inferior. So when you get richer, you consume more of a normal good, so its demand shifts out. When you get poorer, you consume less of a normal good, so its demand shifts in. For inferior goods, when you get richer, you consume less. When you get poorer, you consume more. Okay, so a good is inferior if you consume more when you get poorer. All right, so Dr. Bob, do you consume more or less of Dr. Bob when you get richer? I would think you consume less because you'd rather just consume Dr. Pepper if it doesn't matter to you. Assuming that brand name effects have any meaning to you. You might say that it's normal if you don't really care about brands, but I would think that it's considered more an inferior good. Dr. Pepper, on the other hand, should be a normal good. The more money I have, the more likely that I am to buy soda. So I'll probably buy more Dr. Pepper. Okay. SEPTA buses in particular, I would probably consume less SEPTA buses the richer I get. It's not a great service, no offense to SEPTA, but I don't think I would want to ride the bus if I didn't have to. So particularly now when there's like COVID. So apologies to people who ride SEPTA, but if given the choice, would you ride SEPTA or would you rather take an Uber? I think you'd rather take the Uber if you had the money to do so. I know I would. So I would consider SEPTA inferior. I would consider Uber normal. Next up, these two down here on the right-hand side. One's a beer, the other's a Natty Light. One's like a normal beer, the other's Natty Light. I'd rather consume the fancy beer when I have more money. Obviously, if my money decreases, the fancy beer is going to be more expensive, so I wouldn't want to consume that when I get poorer. So I would consider this fancy beer to be a normal good. I would consider Natty Light, when I'm drinking that, it's usually because I'm in college, I don't have too much money, or I'm in high school drinking in the woods. It's not because I want to be drinking Natty Light, it's because I don't really have too many options. So I would consider Natty Light an inferior good. Okay. Next up, this cool set of Marvel toys versus the Revengers Endless Tussle, the Incredible Fella. This knockoff Revengers thing here is an inferior good. If you go around saying, "Oh, I got this Revengers toy," people are probably going to make fun of you. No offense if you grew up buying the Revengers toy, but if given the choice, you'd rather buy this cool set of, Captain America, Iron Man, the Black Panther and stuff than the Incredible Fella. So I think that the Marvel set is normal. The Incredible Fella is inferior. Oh. And then a cool Carter Hart jersey versus, a plain white T-shirt. Nothing against plain white T-shirts, but they're kind of basic. I would think that you'd buy more plain white T-shirts because you couldn't afford, decked out, Carter Hart jerseys. Unless you're, a Devils fan and you do things wrong and you want to root for the wrong team, then you might want to, buy less Carter Hart jerseys because you might want to buy, a worse player's jersey. but that's just because you have bad preferences. So the Carter-Hart jersey is a normal good because you would want to buy more of them the more money you have. And the plain white tee, again, that might be normal for a lot of folks, but for some folks, I would think it's inferior. So I'm going to use it as an example as inferior good. Okay, so remember a normal good. If I have a normal good, and this is my quantity, this is price, and this is my demand, a normal good should shift out as income increases, and inferior good should shift in as income increases. Okay. All right, hopefully I can wrap this up soon. Apologies for going over, but if you want this, you feel free to tune out at any point in time. This is for you, not for me. I would much rather be eating my dinner right now. So again, feel free to tune out. The answers are all on the slide deck. All right. You're in a rent-controlled city. The demand for apartments is this. The supply is this. A Whole Foods opened up in your neighborhood is very popular. Which of these can be your demand curve? So let's look at the demand curve for a second. 1,000 is my intercept. I have price on the y-axis, quantity on the x-axis. All right. Do I think demand should shift in or out because of a popular Russian? I would think it would go out, right? The Whole Foods basically means this neighborhood is more popular. If the neighborhood's more popular, more people want to buy apartments in that neighborhood. So the Whole Foods is essentially a complement for the neighborhood. So my demand should shift from D to D prime. Which graph does that correspond to? So if my old intercept was 1,000, my new intercept is higher. So it could be 1,200. Okay. Popularity of a complementary good increases demand. The demand curve should increase. Okay. All right, so we're looking at demand curves again. All right, so there's an innovation in slumlording, like your landlord's able to do more in less time. Which of these can be the following demand curve? So I specified here that it's decreasing input costs. It's not necessarily that your landlord will do more in less time, although I can understand your reasoning if you do think that it should be demand shift out. However, in my opinion, first order, like the first thing that would happen is it's just an input cost decrease, and I specify that. So I would hope that you see this. To me, this screams more input cost decrease. So the landlord's able to do more with its time, but that's talking more about the supply function. Okay. So I'd expect supply to shift out and demand to stay the same, such that the price of the apartment might go down. Okay. Not necessarily that the service in the apartment is going to get better. If the service does get better, then you would expect demand to increase. But I don't say that that's what happens. But again, I would understand if you wanted to write 1,200. But really, nothing changes with demand. So I would expect it to be A. Decreasing input costs should only change supply, not demand. Right. So now I have the same question, but I'm looking at the supply function. Which of the following could be the new supply curve? Like I said, the supply curve shifts out because for every price, the landlord's able to basically do more, and so the landlord can serve more buildings or something like that. So the supply of apartments goes up. Which of these graphs does that correspond to? So the old intercept was 100. The new intercept is lower than 100, so it can't be this, can't be this. This was the old one, so it's got to be this. Additionally, notice that this is negative. Okay, So it definitely can't be D. Okay. But the intercept shifts down, so it has to be B. Okay. So if you were unclear about that, it helps to draw out the supply curve and then think, does the supply shift in or out? Okay. It shifts out because you have decreasing input costs, which is one of the supply shifters that are listed in the slides. Okay. And because it shifts out, you can see that the price, the y-intercept decreases. So the price for every unit of quantity, is lower. Okay, or alternatively, at every price, the quantity is higher, you could say. Okay, that's what it means to shift out. Okay. All right, you have a rent-controlled city. The demand for apartments is still the same. Supply is still the same. Price of apartments increases a good deal. What is the new demand curve? Does the demand curve shift in or out? Neither. Okay. Demand already gives you a relationship between the price of apartments and the quantity of apartments, right? On the y-axis, we have the price of apartments. On the x-axis, we have the quantity of apartments, right? That's the market we're looking at. We're looking at apartments. So if the price increases, it's like a movement from here to here. Okay. You're moving along the same demand curve. So it should be A. So that was a little bit of a trick question, and I'm sorry for being a dick, but I want you to understand the difference. Okay. So price is the y variable in the equation. A change in price does not mean the graph should shift, just that there's a movement along the existing demand curve. Okay. So again, demand is a relationship for every quantity. For every quantity and price. So if I change the price, it's like I'm changing the y of this function. Okay, so it could be 200 equals 1,000. Sorry about the handwriting. 200 equals 1,000 minus 2qd. And it goes up to 300 equals 1,000. You know I'm saying 1,000 minus 2qd. But I'm not changing the demand function. Oh, why can't I erase? Oh, cool. I'm not changing the demand function. I'm just changing the realization of it, where I'm changing I'm not changing the function. I'm just changing where the P and the Q are on the function. Okay, it's the same line. All right. So we're in a rent-controlled city, same demand, same supply. Price of suburban housing increases. Okay, not apartments, suburban housing. Okay, what is suburban housing? It's a substitute good. So the price of a substitute increases, demand should shift outwards. What happens when demand shifts outwards? The intercept should increase. So we have D. All right, cool. That's it for the shifters. Next up, we have consumer surplus. So this is just a definition. Okay, so you should be able to answer this without really thinking. So consumer surplus is it the difference between price paid and the cost? No, that's more about producer surplus, right? Cost is given by the supply function. This is the price, P star. So this is your producer surplus. But we're asking about consumer surplus. So not A. The difference between utility and cost. Oh, it's related. Utility will be mapped on your demand curve in terms of willingness to pay, but it's not exactly the same thing. Willingness to pay is related to utility, but it's not exactly the same. Moreover, I say cost. Cost is given by the supply function. So if I say utility and cost, and let's say we were mapping utility in terms of willingness to pay, you'd have this. This would be your consumer surplus, this whole area here, right? With that, we know that's not consumer surplus, that's your total surplus. Okay. What about the next one? The difference between willingness to pay and the price paid. Well, that seems right. This is your willingness to pay is the demand curve, and the price paid is P star. So if I shade enough individual willingness to pays, we get this little area. What's that area? We call that consumer surplus. So boom, 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 we got the consumer surplus, winner, winner, chicken dinner. Okay. And obviously it's not D, though that might be true. Alrighty, pick the Pareto efficient allocations. All right, I'm gonna bring in Excel for this one. The way that I did before. Okay, and I'm gonna move it over a little bit. Or I guess I'll move it under. No, I want it over. So let's do this. All right, I promise we'll be done soon. All right, so I want moving from, going to, P1, P2, and remember, plus, or plus equals, or equals, plus, that means eliminate. If no allocation leads to that, then PE, okay? So basically what I want to do is I want to go allocation by allocation, okay? Moving from, going to, see if player 1 does better, see if player 2 does better, okay? If I have a plus and an equals, that means I've made player 1 better off without hurting player 2. If I have an equals plus, that means I've made player 2 better off without hurting player 1. If I have a plus, that means I made them both better off. If moving from one point going to another point, I've made any of these three things, that means that the moving from point is not Pareto efficient because I could do better. I can make one player better without hurting another player. And remember, that's what it means to be Pareto efficient. If I can move from one allocation to another without hurting either player, and improve one player without hurting the other player, that means that it's not Pareto efficient. Okay. So I have 4, 11, 7, 2. Player 1 does better, player 2 does worse. Okay, there's only one allocation here. There's only 2 allocations. So we have a plus minus, so can't eliminate for 11 must be PE. We've exhausted all the possible allocations to compare 411 to, so it must be Pareto efficient. What about 7-2 versus 411? Okay, this will be minus plus. This is the exact opposite. Okay, player 1 does worse, player 2 does better, so can't eliminate. Can't eliminate 7-2, so that must be PE. Both 4-2, 4-11, and 7-2 are PE. Okay. Okay, next up, we'll do 112. So this is a completely separate example. Okay, so 112 versus 620. Okay, plus. 112 can be eliminated. Both players better with 620. Okay. What about 620 versus, so we don't have to consider 112 anymore because 620 we said is better than 112 already, but 620 versus 12-7. You have a plus, you have a minus, there's no other allocation left. 6. So we can eliminate 620. So it must be PE. What about 12.7? Versus 620. Well, that's going to be the exact opposite, minus plus. So you can't eliminate. Okay, so 620 and 12.7 are PE allocations. They're Pareto efficient. 112 is not. All right. So next up, we have another example. Eight, 5, 16, 17. So this is obvious. This is going to make both players better off. Eliminate 8, 5. 16, 17. Now we can do 14, 12. Okay. So minus, minus. All right. So we can even eliminate 14, 12 because we have a minus, minus, which means that the opposite would be true the other way around. So that'll be plus, plus going from 14, 12 to 16, 17. Okay. What about 16, 17 versus 19, 12? Okay. Plus, minus. There's nothing left. Nothing left. Can't eliminate. 16, 17 must be PE. Okay. 8, 5 and 14, 12 were eliminated. So we're just left with 19, 12 versus 16, 17. So we're going to have a minus, plus. And that's it. So that's number 3. Okay, number 4. 3, 2 versus 8, 13 plus, plus. Eliminate 3, 2. What about, I'm going to skip one for a second. 7, 12, 8, 13 is a plus, plus. Eliminate 7, 12. I want to see if there's any other low-hanging fruit. 17, 4 versus 17, 17 is a equals, plus. Eliminate 17, 4. So we've already eliminated 3. So we're left with 8, 13, 18, 6, and 17, 17. So 8, 13 versus 18, 6 is plus, minus. 8, 13 versus 17, 17 is plus, plus. Eliminate 8, 13. Okay, so we've eliminated 4. We're just down to this is for my own sake. Usually I cross them out when I'm doing it in paper, but whatever. Down to 17, 17 and 18, 6. Right? Just want to make sure I haven't missed anything. All right, so 17, 17 versus 18, 6 is a plus, minus. There's nothing left. Nothing left. Can't eliminate 17, 17 and then 18, 6. And if you understand where this is going, you know you don't really have to do this step because it's just going to be the opposite. Minus, plus. Nothing left. Can't eliminate. $18,600. $18,600 and 1717 are PE. The rest are not. Okay. And there's one more, and then we are done. Donezo. All right, 20. So let's see if I can find anything that stands out as easy to eliminate. 11-14 versus 12-15. Okay, so that's going to be a plus, plus. Okay, what about, so we can eliminate 11-14. Elim 11-14, 7-15 versus 12-15 is going to be plus equals elim 7-15. So I've made player 1 better without hurting player 2. Okay, 16-1 versus 21 is going to be plus equals elim 16-1. So I'm down 3 allocations already. 11-8 versus 12-15. I could also have done one of the other ones. It's going to be plus, plus, elim 11-8. So what's that leave us? So we're left with 21. We've scrapped 16-1. We scrapped 11-8. We have 12-15 still. We have 11. Nope, we scrapped 11-14, 20-11, and 7-15. Did we get rid of that? Yep. And 14-7. Okay, so there's one that stands out here. So 21 to 2011 will be equals plus. So elim 21. So we're down to 3. 12-15, 2011 will be plus minus. 12-15 versus 14-7 will be plus minus. Can't elim 12-15. We're all out. I just want to double check that I didn't miss anything that can improve player 1 without hurting player 2. I don't see anything. All right, so I think we've got them all. Can elim 12-15, about 2011, 12-15 will be a minus plus. 2011 versus 14-7 be minus, 14-7 left? So 14-7 is gone now. Can elim 14-7 because he does better with both. So that just leaves 2011 is Pareto efficient. And 12-15. Okay, so let me just do one more quick round, and I encourage you to do this because it's easy to make a mistake. So 16-11 is done, but it's eliminated by 21, which is eliminated in turn. So I can eliminate both of these guys here because 21 is eliminated by 2011. 11-14 is eliminated by 12-15. Okay, 11-8 is eliminated by 12-15. Okay, so we're left with 12-15, and so far that's it. And then 2011, okay, beats these guys. So 2011 is Pareto efficient, and then 7-15 is beat by 12-15, which you've already eliminated. No, we have not. So right now it's 12-15 and 2011. 7-15 is gone. And then 14-7 is eliminated by 2011. So it's really just 2011 and 12-15 that are standing. So these are the only PE allocations. Okay. And I'm just going to double check to make sure I didn't miss anything. Where am I? All right. 411 620 and 12-7, 19-12 and 16-17. (18-6) and 17-17, and 20-11 and 12-15. All right, so that concludes the recap. If you have any questions, let me know. Otherwise, I'll see you guys with the midterm, or I won't see you guys. You guys will complete the midterm, the 12-15 to 12-12 to 12-15, 10-12 to 10-15. All right, have a good week, everybody. Bye-bye.